Get a minute, don't know. Get a minute of your time. Get a minute of your. Let it. I sure gotta live right, and I'm never gonna let you out of my side. I've been knocked out, was a nice try, but I guess I get to keep my head on this time. Part of the creation, the relations I've got. The only one that gives me safe, the only one you should trust. For sure, it ain't right that I have checked the speck of dust from all of its sides. Fall down, not from my height, cause I didn't see the plank I had in my eye. But you in yourself when no one's to be found. What keeps you eased out? What takes you off your mind?
Yes, you want this, I want this. Everybody in this, we should have it. Stop illusions, it's in your hands. Show yourself, reveal it to them. Take the time to recognize it. You won't leave me even if I tried it. You're the artist, I'm the mass and happily perform the new in your hands.
I sure gotta live right, and I'm never gonna let you out of my side. I've been knocked out, was a nice try, but I guess I get to keep my head on this time. Part of the creation, the relations I've got. The only one that keeps me safe, the only one you should trust.
Yeah, you better.
For sure, it ain't right that I have checked the speck of dust from all of its sides. Fall down, not from my height, cause I didn't see the plank I have in my eye. You in yourself when no one's to be found. What keeps you eased out? What takes you off your mind?
Yeah, you better. Yes, you want this, I want this. Everybody in this, we should have it. Stop illusions, it's in your hands. Show yourself, reveal it to them. Yeah, you better. Take the time to recognize it. You won't leave me even if I tried it. You're the artist, I'm the mass and happily perform the new in your hands. Yeah, you better. Yeah, you better. Yes, you want this, I want this. Everybody in this, we should have it. Stop illusions, it's in your hands. Show yourself, reveal it to them. Yeah, you better. Take the time to recognize it. You won't leave me even if I tried it. You're the artist, I'm the mass and happily perform the new in your hands.
Puesto comiendo sopas en el aire diviso, un ángel que le decía, ha nacido el Redentor. De oriente salen de reyes para adorar al Dios niño, y una estrella le guiaba para seguir su camino.
right, folks, we're going to start in 1 to 2 minutes. So get on over here.
Check the sound. Is it on? Okay. I can hear myself now. Whenever you're ready, Chris. Let's do this.
Okay, let's get started. Hi, my name is Chris Cool, and I am a I'm a program manager at Microsoft. I came to Microsoft through an acquisition of Kinfolk, where I was one of the founders and CEO. And Lexi and I started doing this over 3 years ago, and so yeah, it's of course some things have happened between there. But this is our Sorry, I touched the key. Yeah, this is our first fully scoped event in over 2 years. So welcome everybody. Rejects exists because there are so many good talks that are submitted to KubeCon and then subsequently rejected. I am pretty sure there's probably more folks who have gotten rejected from KubeCon than have been accepted, and we like to play that place for those folks, the rejects. The last rejects event we did that we were fully able to gather here was in San Diego, and that was in the fall of 2019. I know some of you were actually there, and so we're really happy to get back because at that point we had done 2 events, and we were looking forward to going to Amsterdam and having the momentum was growing, it was getting good, and then all of a sudden, just like with the rest of the world, our plans fell apart. But we're super happy to have you back here and at Rejects in full swing. And like Lexi was just saying, the first time we did this was only a few hours away in Barcelona, so it's really happy to kick this off again in Spain. So before I get to some thank yous, which you will be one of those, Lexi, I'm going to hand off to you for logistics.
Thank you so much, Chris. So I'm Lexi. I also work for Microsoft now through the acquisition, but before that, I was doing all the events at Kinvolk, and now I'm doing the events at Microsoft. So that's me. So welcome to you all. Yes, after 2 years in quarantine, pretty much, I'm really excited to get in-person events started again. It's been just really challenging to connect virtually. I just don't feel like it has the same ring to it. We can't connect. We can't really have that sidetrack that we really enjoy with Rejekts. We're also streaming to you live. So hello to everybody at home. I am also mostly here to give logistics, but I also want to give some thank yous because getting in-person conferences started has been quite challenging, as a lot of you, well, some of you might not know, but knowing what the logistics are locally and what to do, it's just been really difficult. So I wanted to thank the program committee, which was essential to get our talks together. Benazir Khan, Andy Randall, Ashish Mishra, Tejas Sampura, and of course Chris Cool. Very cool. And a really special thank you to Thilo Frum, who drove all the way from Berlin here. If you follow him on Instagram, you'll see a lot of beautiful landscapes. But he actually brought a lot of our collateral here all the way from Berlin, which was a huge help. So thank you, Rockstar. Back to logistics. We have 2 rooms, 2 tracks, main and gallery, which is right behind you. For those at home, you can find both of the links on our YouTube channel or on Twitter. And our Twitter is @rejektsio, which is REJEKTSIO. What else do we have? Oops, sorry. Give me just 1 second. Oh, there we go. On the other side of the page. Right. So we are streaming live. So I know sometimes the quality is not as crisp. So please just bear with us. We are going to be releasing all of the talks individually in high definition over the weeks. So our AV team is amazing, and they're doing the best that they can. Technology, right? We're also requiring everybody to wear face masks indoors unless you're eating, drinking actively, or if you're speaking, obviously. We are sanitizing all of the microphones, so we're doing the best we can, right? What else do we have? We also have this outdoor area here where you can take off your mask, get a break, catch some sun. What else? We also have these really great wristbands just to have the comfort level. So you know if people want to social distance, if they're cautious, or if they're just, like me and just want to hug and say hi. So that's that. Snacks and beverages are available in the cafe, as some of you have already seen. And they're free. Yes, they are free. The special thing about this conference is that, it is on the weekend. You're going to be at KubeCon for the full week and indoors and eating conference food. Let's just be frank about it. It's not the best. So we really think that the special thing about our conference is that we give a really long time for lunch so that everybody could go out and actually experience the local cuisine. In Barcelona, it worked really well. Everybody really went out, had a good time, did some sightseeing. In San Diego, I think we had a really good taco place that catered. So regardless, we really want you to immerse yourself in the local culture. What else? And also, you could also stay around here and enjoy the co-working space. I think that is it from me, Chris. I just hope that you guys enjoy this community event, and thank you for supporting us.
Okay, thank you, Lexi. Yeah, it's very interesting doing public speaking now, when you're not in front of a screen in your pajama pants. Yeah, okay.
You have pajamas?
No, yeah. Yeah, and so before we kick it off with the first presentations, I would definitely like to thank Lexi for putting this all together. You know, going to Microsoft and having a whole new set of requirements for procurement has been a very big challenge. You know, even outside of the whole COVID challenge. So you know, a lot of thanks for your efforts in there, and it's great. Next,
It's for you guys. It's for you guys.
And I would like to, Benazir, who's at the registration, or back there in the back now, she just joined the team a month ago. She's jumped in, done a lot of help right at the end. This is her first community event, you know, first interaction with this community. Please make her feel welcome. Thanks, Benazir. And like Lexi said, the program committee, thanks for everything. There's a lot of, you know, work they do to look through every single talk, you know, find out, you know, curate this event. So a lot of thanks to them. We have the venue folks. So one of the key characteristics of Rejekts is that it's not a typical, we try not to find the typical conference location. I think you all see this is a really comfortable location. You know, somewhere you want to hang out. And so, you know, thanks to the venue folks for, you know, helping us set this up, because this is not the general layout. They have these awesome tables, by the way. They're amazing. But yeah, thanks to them. And last but not least, thanks to the volunteers. So those are the folks who, like down here, are helping the current and next speaker, the registration folks, the people running around. So thank you to all of them. And if you would like to help with the next one, you can talk to Lexi. It's going to be in Detroit. And again, thank you to all of you. We hope you have a great weekend. And let's get started with the first talk.
Actually, I just wanted to say one more thing, just because I did mention that there's an outdoor space. If you do want to take another break, you would have to wear a mask, but there is another room back here that is streaming the main track, and you could just hang out there. So just wanted to let you know that there is another room, okay? But yes, Chris, go ahead. Sorry.
No, I think we're good. Let's get this started.
Well, hey, thank you everyone for coming today. My name is Christopher Newland, and today I'm going to be talking to you about how we migrated a large Fortune 100 company to Kubernetes in 7 months. So just a little bit about myself. I'm a consultant with Red Hat. I've been there for about 4 years now. My specialties are in migration, specifically for Fortune 100 companies. So we're usually dealing with migrations of at least what would end up being 1,000 to even potentially 5,000 namespaces. So usually significantly large migrations. I've been involved in the container space for 15 years. I started in college doing research around OpenVZ that then spun out into a company that I started right out of college that worked with the Department of Energy on containerizing simulations for the Titan supercomputer in the United States. So after that, I worked primarily on microservices, and then since then I've been with Red Hat and have specialized mostly in the migration space, some recently in the edge space. In the last year, I've become one of the main speakers for the conveyor community, and I'm going to be talking a little bit more about conveyor and some of the technologies here today. So just a quick overview, we'll be talking about this specific use case in detail, and then we'll be talking about some of the technologies that we used at the time, and then how those technologies have evolved to be part of the conveyor community and what the community is about, and also some of the lessons learned and best practices here in 2022. So a little bit about this company. It's a major healthcare company in the United States, Fortune 100. It's a conglomerate of over 20 companies that formed to make this company. And the IT budget, I remember the first day I got there, when people were talking about money, everything was in the millions, multi-millions, and I just had to ask someone, so what is your IT budget? And one of the VPs looked at me, he's like, roughly about $1 billion. I'm like, oh, all right. That gives me an idea of what I'm dealing with. And they also have a large overseas presence. So most of their IT staff are located in India with companies like IBM, which is now Kyndryl, what was IBM, now Kyndryl, and companies like Accenture. So a lot of overseas presence, a lot of overseas developers. So the migration first started with a Mesosphere component. This company needed to get off of DCOS within 7 months. They had a contract with them that was expiring, and it would end up being a multi-million-dollar issue if they weren't going to get off within that timeline. So there was a strict deadline that we were under. We had started piloting OpenShift 3.11 with them about a year prior. So we had about 50 or so namespaces that had existed on the 3.11 cluster, and we were also helping them spin off some EKS instances at the time. So we were going for a full hybrid cloud architecture for both on-premise and cloud-based, where OpenShift was the primary on-prem and the EKS was going to be the primary for cloud-based. Most of their applications were uncontainerized at the time, so they had done about 150 in DCOS that were in production and about 300 that were in non-production. And great. Okay, there we go. Sorry, I'm getting some feedback. No, you're good. All right, there we go. Yeah, so about 300 applications that were in non-prod, 150 that were in prod. The discrepancy between the two are because a lot of the applications that were running in non-prod were actually sandboxes where they were attempting to migrate many of these applications. So we were dealing with kind of a crazy environment at the time. One of the big things with this too was that they were using the Netflix stack in DCOS. So if you're not familiar with that, that's Zool and Eureka, mainly around service discovery and inter-service communication. So after talking with them, we identified 3 different types of migrations. The first was the DCOS one, which I pretty much described just now. The second one was a Kubernetes to Kubernetes migration. So that would be the OpenShift 3.11 instance that we piloted with them. They wanted to get off of 3.11 and get on the newer OpenShift 4. And they also wanted to migrate those same applications into EKS as well. So we had a full hybrid cloud migration going on from that initial on-premise pilot. And the third was all the uncontainerized applications that they wanted to bring over as well during this time. So primarily Java applications, and like I said, this is probably the majority of the applications that they had. I'll go over some of the challenges. One of the big things we had to do initially was just getting buy-in from their application team. So these are the end users that would be consuming the clusters once deployed. A lot of them had very much a throw over the fence mentality towards development, especially with how they've been working prior to moving into Kubernetes. So one of the things that I like to stress with Kubernetes is that it is an ecosystem. It's not just an operating system. And it needs to be treated as such to get full utilization. And a lot of that comes with principles like DevOps and GitOps that when used, those methodologies allows you to drive those technologies. And then just making sure to train those teams on basic K8S core principles, Kubernetes, what is a deployment, such things like that. And one of the things that came out during this time, and I want to highlight this, always make sure you're involving security teams when you're doing migrations. They had not been involved with the DCOS component, and so I said, hey, I think we should talk to your security team about some of these. And we had two major things come up during that time, which was all of their containers were running as root on DCOS, and then they were also terminating at their load balancer instead of passing through to the actual containers. So those were two other things we had to tackle while working on this migration. I'll talk a little bit about the high-level approach for our migrations. So this is actually on conveyor.io. So this is not just me. This is actually part of what we've developed as a community. And these are the 5 steps that, especially when you're talking to like a project manager, business analyst, director, these are the type of steps that we like to talk to with them, a very high-level overview. And this is bigger than these for a reason. I cannot stress enough, spend as much time as possible in the assessment phase in a migration. If you rush this, all these other ones are gonna fail, because this is where you're gonna find out what you're having to tackle and how you're going to group those up, which I'll talk a little bit more here in a moment. This is where, I was talking about grouping. This is where I coined the phrase the bucket approach. Talk about that here in a moment. And then I'll show this here as well. So the approach that the terminology I use within Red Hat with my clients is what I like to call the bucket approach to migrations. This is a little bit different than how I find companies want to naturally do things. Usually it's based off of, I've even had clients say alphabetical. They just want to go alphabetical on the migration, or they want to go with the sales team first and then over here. And I like to try to take a bit of a different approach to migrations. And I found that the migrations that have taken this approach have been maybe 30 to 40% more efficient. And I'll talk a little bit about that here in a second. But the bucket approach for me is always finding common patterns, common integrations, and common domains. Making sure to group up applications that are similar. So if you have a group of applications that are running off of, let's say, Django, and they're all stateless, or excuse me, stateful in that case, then that would be one of your buckets. And it doesn't matter if one's over here, one's over there. Like, you want to make sure that you're grouping it up from what are most alike, because these are the patterns that you're going to figure out, and then you're going to be able to do all of these in one bucket from a migration perspective. It moves a lot faster when you're not having to switch between these constantly. Focus on a particular domain technology domain and focus your migration around that. I have had challenge getting buy-in from companies on this, but once I've shown them the results, they've always fallen in line on this. Because like I said, a lot of times they want to start with a particular business unit, but once we sell them on this, we've shown some pretty significant results on it. This is the 5 steps. So this is more towards your people who are executing on the migration, specific to Kubernetes. I like to take a 5-step approach for that as well. I always start with images first, because that's going to be the basis for everything. You have to have the image before you can really deploy anything. In this case of this migration, we just wrote our own scripts to do this, but there are some tools out there that can speed this up as well. I then like to take things from a cluster level perspective. So the namespace, things like quotas and network policies, anything that we manage by a cluster administrator or as a cluster level resource, I like to get those out of the way first because it can identify problems that you're going to face with these 3. The 3rd step, and probably the most problematic if you're have a stateful migration, is always going to be your volumes. This is where I always try to have people who can champion for the particular client in the area of their storage, because again, this is where there's a lot of complexities here. I could have a whole session just on this. But you want to have this happen before this, and even preferably this. There's a bit of a chicken before the egg problem sometimes between these 2, but I find this one works better. For security, I like to focus on your RBAC policies, access controls, things of that nature, and that then makes sure that by the time that you're ready to actually deploy your manifests, that you have a high level of confidence that all these foundational pieces will allow your application to deploy in the first time. Hopefully, fingers crossed. And then these are the type of, like I said, you have your cluster managed objects, persistent data, secrets, manifests, and so forth. So going back to those 3 types for this particular use case, for type 1, like I said, we started by migrating the images to a Quay repository that was located on-prem on the OpenShift 4 instance. And then we were generating the initial KAS resources using templates. So we were using a combination of Helm and OpenShift templates. But one thing I want to highlight, at that time, this was not available. So definitely check out Move to Kube. Move to Kube is a part of the Conveyor community, and you just point it towards your application, and it'll actually generate these initial resources for you. That's very helpful because the way we targeted this migration was using Argo CD and GitOps. So we would export those resources, put them into Git, and that's actually how we would execute at least that portion where we had the diagram, how we executed on the resource part of that migration. This part was pretty easy, and we just made some documentation for application teams to remove it. And then similar with this requirement too. We let the application teams drive these 2 and gave them just the blueprints. Type 2 for Kubernetes to Kubernetes. We also used Argo CD in this case, very similar to the first slide. From a storage perspective, though, we used the rustic operator. This has now been incorporated into Crane. Crane is another one of the projects of the Conveyor community, and it's specifically designed to migrate from one Kubernetes instance to another. Doesn't matter what type it is, if it's OpenShift, if it's Rancher, EKS, JKS, it's been designed to go between any type of Kubernetes. We did this at a namespace level. We also put a load balancer in front of the OpenShift 3.11, and every time we finished a migration, we would cut that over from that load balancer sitting in front. So it would split the traffic by namespace. This took about 2 hours of downtime, so I wanted to highlight this because this is an improvement that's been made. And mainly because of the storage component side of that, where we didn't want to deal with data drift or anything involving that. But if you use Crane now, Crane has a lot of functionalities where you can stage the migration in place. You don't have to bring anything down. So all you have to figure out is how you're going to do that cut over and switch your traffic from one location to the other. But Crane will do that very, very effectively for you. So this is, like I said, part of the conveyor, one of the conveyor projects in the conveyor community. The type 3 was a combination of greenfield applications and applications that were legacy or pre-existing. Most of them were on Java WebSphere for us. And there was actually a few hundred of these while we were there. So this was a pretty major effort. And the big ask that we had from the client was to define the cloud readiness for each of these applications. We were using a tool called Pathfinder at the time. This was a Red Hat tool. That has since been adapted to the conveyor community as a product called Tackle. Tackle will do an analysis of an existing application and give you like a rating of how ready is it to be a cloud native application. It'll also give you remediation advice as well. So a really cool tool. One thing that we weren't expecting was that the client also wanted to get off of Liberty from their WebSphere. So we also moved them over to a base image for JWS Tomcat. This ended up having a massive cost savings element since this is one of Red Hat's open source images, so free to them. And then the containerization was mainly led by the application teams. Most of these were overseas application teams, and we just enabled them through some workshops to handle that migration. Ultimately, they were going to be responsible for that. The accomplishments, we did get off of DCOS. We got off in 8 months. They did extend it for 1 month, but we were actually finished within the 7-month time frame. What ended up happening, and this is something that I've since learned to ask all my clients, there was a DR server that we weren't aware of that we needed to move things, actually they needed to move things over to, that wasn't part of our migration. So always make sure you're asking about your DR when you're doing migrations as well. Like I said, we containerized over 100 services in parallel, so this was driven by their application teams. And we also got them off of Docker Container Registry into Quay on the OpenShift 4 on-premise. They were also using Bamboo at the time, and a separate team, Red Hat team, moved them over to Jenkins within that year as well. So this was a major cost savings as well, since this was an open source version of Jenkins that they were using. And then we planted the seeds of DevOps. I like to say that a lot. I wouldn't say we got them there because that's something that takes a lot of time, but our team definitely planted a lot of the seeds, and even since I've left there a couple years ago, they've adapted their DevOps practices significantly. The shortcomings, we did have a lot of the overseas teams that really struggled taking ownership of this process, treating Kubernetes as an ecosystem. Thankfully, we had buy-in from their leadership, so we were able to put pressure there. But that's one area, if you don't have that type of buy-in, you can have some real issues, especially if you're on the consulting side of things. This could be a real problem if you don't have that buy-in. Some application teams, like I said, were unwilling to then take ownership also for the DevOps and GitOps perspective. Thankfully, I would say about 80–90% were good with it, but we did have some ones that we had to do a little more hand-holding on. We did have some challenges too with them being enabled on Kubernetes. This is just because of the nature of it being a 7-month migration. I would recommend if I had to pick a timing, I think they should have at least done a year, because once they got over to Kubernetes, they didn't know how to take ownership of it. So there was some hand-holding from that perspective as well, where we had to teach them what is the deployment, what is the secret. Since we didn't have that opportunity up front, there was a lot of education going on. One issue too we ran into was just logging. I'm sure we've all faced this. It's Kubernetes. Thankfully, they made the decision to just then forward to their Splunk instance. So that was something that we had to identify mid-migration. And then the manual lift and shift of DCOS. So this is where move to Kube comes into play now. We were doing this through Helm and manually copying things over. Now something like move to Kube can do that for you, where it generates those manifests. This is just outlining those different products I mentioned. I'll talk about Forklift here in a minute. It's the only one that we haven't talked about. Move to Kube, we've talked about Tackle for like an analysis, and then Crane for the Kubernetes to Kubernetes. And this is more about metrics-driven transformation. So I'm not talking about that today, but just know Polaris is also part of the conveyor community. So let's talk about some trends that we're seeing today. I would say the biggest thing that I'm talking about with my clients is container native virtualization. This is something that's coming up nearly on a daily basis for me. There are organizations that want to move all of their VMs over, and there's some that want to bring over some legacy snowflakes that they just recognize are going to be too challenging to containerize, and would instead like to just bring it over so that it exists within the Kubernetes ecosystem and its networking and storaging components. This is where Forklift comes into play. If you're using VMware, if you're using Red Hat virtualization, KVM, you can just actually lift and shift using this tool, and it'll help you do that. I know we're expanding it to include some other hypervisors. I'm not sure what those are right now, but I know this is growing right now. And then, like I said, just a focus into hybrid cloud. The big theme I'm seeing in the last couple of years, now that Kubernetes has been maturing, is more and more people want to bring their own flavor, kind of bring your own cluster, especially with these larger companies. So a lot of the people I'm working with right now have JKS, EKS, OpenShift, Rancher, multiple flavors that exist within their entire organization. And the good part about that is that Kubernetes is built with that in mind. So that's one of the beauties here, especially from a migration standpoint. These tools don't really care about what your source is. From a cluster management perspective, though, it definitely adds some complexities. And then just going to the edge. So a lot of these companies I've worked with are coming back to me and saying, hey, Chris, we've gotten this all set up. We're feeling enabled and empowered. Our people now want to move from our data centers, get into our factories and our on-site locations, our stores. How do we do that from a migration perspective? So these are conversations I'm having right now with a lot of my clientele. If you're interested, we also have a report on conveyor.io about application modernization in 2022. So there's a lot of information here on the trends I was just talking about, and then some of the challenges more in depth of what I've been talking about today. But that's a really good resource if you're willing to learn more. And that's all. Thank you. I think we have a couple minutes for questions. Yeah. There in the back? Yes. So it was about a 30% tech debt, well, what they were labeling as tech debt. So they were committed to me for about 30% of the time, and then they still had about a 70% velocity for their day-to-day agile practices. Over there?
During those migrations, you've been naming the refactoring cost.
Yep.
How much refactoring they have to do before they can actually go to
So about 70% of those fit a standard, what I would say, template of like a Liberty Java application. In that case, we minimize that quite a bit just by having some documentation about what to modify in their Spring Boot configurations. So that was pretty minimal. We had about 20%, which I would label snowflakes, and that's where they had to spend a little bit more time. They didn't migrate as soon as some of the others because they were labeled as such. But that's where something like Forklift can come into play, where we can get them in sooner through like a VM approach instead. But yes, that was a challenge for us.
What are some of the interesting challenges of like moving VMs into KubeVirt with Forklift?
Yeah, so some of the challenges I've faced is probably the number one is bridging from a network perspective. So if the client wants to be able to reach externally to their own network, making sure to define those bridges appropriately. So if it wants to connect to the pod network and to the external network, that's where you're doing some networking magic and making sure you have that set up appropriately. And that's where I make sure that my clients have their network engineers ready, because a lot of times there's questions from that perspective where you need to define things from an external network standpoint.
Are these applications usually architected in a way where they can scale to multiple virtual machines, or just like a...
I have one right now that is scaling to multiple. I have one client that has a VM on each node on a 3-node configuration. Mm-hmm. Correct. Now that's by their design though, so that's from an application standpoint. Oh, I'm sorry. Any other questions? Oh, Becky? Yep. So the question is, what metrics were we using to define the bucket approach? For that, I actually have a diagram that I use, and then I'll modify it on a per client basis. And I'll try to find what's the most common denominator. So Python to Django might be it, where I say, okay, that is a big common denominator for here. And then I will group those up from that perspective, and then try to find other things like, okay, are they using Microsoft SQL? Are they using this? And if I find, there's a term for those graph diagrams where you get like bubble diagrams, I use that. So I'll take that information and then make those bubbles and try to find the biggest one and then go with that. That's how I usually do it. And I use pie chart for that usually to make those diagrams from that perspective. I think we have one more. I think we're about to run out of time, but it was real quick. We might have to take it offline.
What was after? Did they evolve? Did they scale?
They did.
How was the
Significantly.
resistance after? I mean,
They have over 5,000 namespaces now, and there's 3 different Red Hat teams working with them, and they've completely moved most of their operations into the cloud from a combination of OpenShift and I think now AKS. So it grew. They were empowered on the technologies, and a lot of their application teams have grown along the way as well. Okay, that's time. If you have another question, feel free to take it offline with me, and thank you for your time.
On va avoir le même problème de l'autre côté, donc il va falloir courir entre les deux. Si c'est trop chaud de courir entre les deux, demain je dis à Sarah de venir. Ok? Je vais voir si ça va. Hein? J'ai pas de meeting.
No, c'est possible. Sí, je la vois. They need each sheet ahead.
That's a good question. Let me ask Bill, one quick question. He's asking for... do we need to film all of the speakers? Okay. No, I don't mean the whole thing. I mean, they have to appear in the summary, in the highlights video. They have to appear all of them, or it's not necessary?
Otherwise, I mean, some of us...
I'm asking this because sometimes you're going to be speech here and speech there, and maybe I'm here and I'm missing the one there. I don't know if it's completely necessary that they are all filmed for the highlights. No, it's necessary to film all the speakers. Not all, but they have to appear all of them in the highlights. Okay.
Should we?
All right, up next is Alban Kreki from Microsoft, and Wesley Burmach, did I do that correctly?
Yeah, Bembach, yeah.
From SAP, how we made our availability metrics more meaningful with eBPF.
Great, thank you.
Thank you so much.
Okay, so my name is Wesley. This is Alban, like we were just introduced, and welcome to our talk on how we made our availability metrics more meaningful with eBPF. So, who are we? I'm Wesley. I'm a software developer at SAP. There's my GitHub as well, my email in case there's any questions or if you'd like to follow me on GitHub. And I'm currently working on an open source project called Gardener, where we provide Kubernetes clusters as a service. We use it at the company, but it's also open source if anyone wants to try it. And we'll be talking about it a little bit more in detail in the presentation.
Hi, I'm Alban. I'm a principal software engineer at Microsoft. I used to be at Kinfog before, and I'm working mostly on a project called Inspector Gadget, and is doing eBPF and Kubernetes work.
Okay, so we'll get right into it. So we have availability metrics in the title. This week is the KubeCon, so not surprisingly, we'll be measuring the uptime of Kubernetes clusters. And these clusters are created in the context of Gardener. So we created this project, or we started this work because Gardener creates Kubernetes clusters. This Kubernetes as a service. We use it internally at SAP, so internal departments will come to us. We provide an API for them and can provision Kubernetes clusters for them. So they can say they would like a cluster from AWS or Azure or GCP, and we provide just normal vanilla Kubernetes clusters for them. And what we want to do is we would like to measure the API server uptime of these clusters, just to measure how good our service is. And what we want to do in this talk is we want to improve these metrics and make them more meaningful. And one way to do that is, or one important thing to define first is SLAs, or service level agreements. Maybe most of you have already heard about what this is, but just in case, we have I have a screenshot here of this uptime.is, and you can enter in a target SLA. So like, for example, 99.95%. That means the service provider and the people using the service. So in our case at SAP, it would be Gardener, and the internal Gardener would be the service provider providing Kubernetes clusters, and the client would be the internal departments consuming the Kubernetes clusters. And if we promise, for example, 99.95% uptime, that means our clusters should be up that amount of time. And then there's also this concept of error budgets, which means basically just defines how much downtime are you allowed to have and still uphold your SLA, so still maintain your agreement. And then there's like different periods where you can define that. So for example, if you want to maintain this SLA for a day, hopefully you can see it here. It says it has like the daily. That's like 43 seconds. That's not a lot of time. And it'll come back again a little bit later. And then you have different periods as well, like weekly, monthly. Like the monthly, for example, is almost 22 minutes that you have available as potential downtime. So where does this name Meaningful come from? So this project was inspired by a paper from Google called Meaningful Availability. And I don't want to get too much into the details of the paper, but essentially what their aim was to provide metrics that were more meaningful in the sense that the metrics really represent what the user experiences. Because you could have, for example, like some synthetic metrics that measure the uptime of your service, but does it really capture what the user experiences? And this is something that we wanted to do for our service as well. Okay, so I'll start maybe with something that wasn't working for us, or that is maybe less meaningful in a sense, and that would be probing the API server at specific intervals. So this is a pretty simple way to measure uptime, and this can lead to some problems. So if you probe the API server once per minute, maybe it says that it's up all the time, but in between the minutes that you're probing, you have a bunch of downtime. But you don't really know because you're probing it, and you don't really know what's happening in between there. So in essence, this isn't really representative of what the client experiences, and we would like something better. And also, if you remember, we had, so for the 99.95%, you have 43 seconds of downtime per day. And if you want that fine granular metric, you have to probe your API server once per second. At that point, you're basically DDoSing your API server. Okay, it should be able to handle the load, but you're just adding unnecessary load to just get these 1 second granular metrics. And also, it could also be that the API server is up, but for some reason a connection failed, and you don't really know why. So what did we do to create meaningful metrics? Yeah, so how did Google do it in their paper? What they did is they processed access logs. So like if there was a 500 HTTP code and it's a failed connection versus like a 200 code, then they could process it as a successful connection, and then they put these metrics into time buckets. So they annotated time and said, okay, 1 second is successful or not successful based on if there was a failed connection or not successful connection. We can't do this so easily in the Gardener architecture. So like I said, this project is made in the context of Gardener. And we can't necessarily process the access logs. Okay, we could process the ones from the API server, but then we raise the question, what do we do or how do we evaluate it whenever the API server is down? And that's kind of difficult. We also have a reverse proxy that proxies to our different API servers, but there the connections are all encrypted, so we can't process those either. So we had to do a different approach. Okay, we could change the architecture, but we wanted to explore some possibilities with eBPF. What could we do? And that's what I'm going to talk about. But first, we should get into the Gardener architecture a little bit so that everyone's on the same page. So in Gardener, we have this concept of shoot clusters. That's these ones right here. This is what the client, so the user of the service gets. They just get a normal vanilla Kubernetes cluster, which has a workload. You can run some pods there. It's a normal Kubernetes cluster, except for one thing, and that's the control plane is hosted on a separate cluster. That's what we call a seed cluster. That's over here. And then hopefully you can see the different colors. I color-coded the shoot clusters, and they all get their own corresponding control plane where the API server runs. Okay, there's also a few other pods, but for this presentation, the only thing we care about is the API server. Then we also have a component there, the envoy, which acts as a reverse proxy to send the connections to the correct API servers. And it does this using something called SNI, or server name indication, which is important a little bit later on. And the SNI is basically just the host name of the API server. Or it contains, so for example, it would just be like blue, red, or green, and it's an unencrypted thing that we can process. And it kind of looks like this. So the envoy is able to distinguish the connections based on the SNIs. So for example, you might do like a kubectl get pods. And then the first thing you have to do is you have to do the create a TCP connection. So you send the SYN, get the SYN ACK. It's quite normal. Then you establish a TLS connection. And what the client has to do is the client has to send a client hello. And this client hello contains the SNI. So for example, if the blue cluster is doing this, then the SNI would say blue.cluster or whatever the host name of the API server is. And then Envoy can process this and route it to the correct API server. The server then responds with the server hello. We've established a TLS connection, and then we can just have our HTTP traffic as normal, which is encrypted. And from Wikipedia, in case you're interested, this is the definition from Wikipedia. So we'll go over this network path once again. This little tiny orange blob here is a client hello. We'll follow the path of the client hello in this architecture. So a pod is perhaps doing a kubectl get pods or watching pods, for example. And so what happens is it goes to the seed cluster. So we have a single load balancer on the seed cluster. We used to have multiple for each API server, but we introduced a cost-saving measure to only have a single load balancer, so we don't have to have a load balancer for every API server. So then it lands on a random node. And then there's Kubernetes networking happens, and it lands on this envoy. And this envoy does the routing based on the SNI. Okay, this came from the blue cluster, so we route it to the blue cluster's API server. This is how the architecture works whenever everything is healthy. And then if it's unhealthy, the same thing happens. The client hello ends up on the envoy, but it can't send it to the API server. So then we get a TCP reset packet. And this is sent back the same way that it came, so it goes on to the random node where it was, and then it ends back by the client, and the client knows, okay, my connection failed. And this would be a failed connection in our case. And then where the magic comes in is we have a component running on every single node cluster, which is this red diamond here. And so we deploy a daemon set in our seed clusters, and we can process these connections. So we can evaluate if the connection was failed or successful based on if an RST packet came or if one didn't come. And then we can expose some Prometheus metrics and process this data. So for example, the Prometheus data could look something like this. We just expose a counter metric for those of you that are familiar with Prometheus. So it always just increments. And we say how many seconds were successful, how many seconds were failed. So those are the first two metrics. Hopefully the text is big enough, but here we have the kind active, and we also know which SNI it belongs to. So we could do this mapping to which cluster it belongs to as well. And we just increment the seconds, and then we have this active failed, which means there was a connection, there actually was a connection, and it failed, which means this RST packet came. And then finally we have this just normal failed, which means the last second that we know about was a failed connection, and there hasn't been any traffic since. Yeah. Then we scrape this data with Prometheus, perform some PromQL queries on it, and then we can finally visualize the data in our on a Grafana dashboard. And we have some fixed time windows, so that means from Monday to Monday, for example, or every hour, we just reset these counters, and we can start measuring the SLA again from there. And now I would like to move to a demo to actually demo this. Okay, so I have a few terminals here. Let's just reset them. So on the right side, I will start a watch on, so this is one of the control planes that we have of a cluster. So I've created a demo cluster here. Hopefully this all works. Okay, there's quite a few pods. The only one that we care about is this Kube API server. So this is the one where we're measuring the uptime. And I will restart, so I will kill this pod. It will get restarted because it's a deployment. And then hopefully I will be able to show you the Grafana dashboard and see that there was actually a downtime. So I delete the API server. Hopefully we see that it restarts. Yep, you see it's restarting. Perfect. Yeah. Okay, maybe I will just open up the entire terminal then when I show the next things. But yeah, it's terminating here. Hopefully you can see that. I deleted the pod. Then here we can. Then I just want to show off the daemon set. So we have a bunch of pods running in a separate namespace. This is just the daemon set. And if we do a k-top pod, we can also see that they're hardly using any resources. So they're using like one millicore and barely any memory as well. So it's quite efficient. And then finally, we have some monitoring as well. Just the Kube Prometheus stack. So it's just a Prometheus and a Grafana. And I will port forward to the Grafana and showcase the dashboard, and hopefully we can see this downtime. So first of all, I'll make this a little bit bigger. So here we can select the period. So if we want to know the SLA for the week or for the calendar month or for the day or whatever. So here we have the week selected, and we can see all the S&Is that we're tracking, how many are within our air budget, and how many are exceeding it. Can filter it as well up here, and then we can go to the demo cluster that where I just restarted the API server. We should, okay, because I changed the resolution, we don't see the percentage. Yeah, you should also see the uptime percentage here, but because I changed the resolution, you can't see that. But yeah, we can also drill down to this as well, and then get a better overview of everything as well. And then, for example, for the hourly SLAs, we can see, okay, something happened here. There was a downtime, and we can see how many downtime seconds there actually were. So there were, okay, restarting the API server caused 4 seconds of downtime. So we can really measure it down to the second granularity because we're capturing these packets with eBPF. And then also, again, we have the same view as in an SLA form as well, and we can see, okay, now we have exceeded our error. Yeah. Okay, I restarted it earlier as well a few times, so now for the hour, we've exceeded our budget, for example. Okay, and then we have the same views for the days, the week, and the calendar month as well. The cluster hasn't been running, it's not the entire, cluster hasn't been running for a month yet, which is why we don't see the data for the entire month. Yeah, that's everything for the demo, and I think for the next part, Alban will explain in a little bit more in technical detail how we did all of this with eBPF. We will continue.
Can you hear me fine? Cool. So to be able to do that, we need to look at the packets and distinguish which connections are successful or fail. In this example, we look, for example, on the right, there is a TCP reset packet, and we consider that a failed connection. On the left, a successful connection. And how do we do that with the BPF? First, what is the BPF? It's like a small program that runs inside the Linux kernel. There are different kinds of eBPF programs about networking, about tracing, about security. In this case, in this presentation, we only care about networking. So it looks like that is a C function that will be executed for every single packet that comes on the network. And the parameter of that function is a network packet. And inside that function, we will be able to look at the content of the packet. Like in this example, we can see if it is a TCP packet, IP packet, and so on. How do we install an eBPF program in a Linux kernel? First, we have an agent, which is a user space program here written in Go. It will install the BPF program in the kernel using the BPF system call. It will install maps as well. I will come to that. And then, once it's installed, every time there is a packet on the network, it will execute a new instance of the BPF program. It will execute it again and again. And the BPF program will be able to update eBPF maps. So eBPF maps are like a global variable on the system. They can be of different type, hash table, array, and so on. And those variables can be read from user space as well. So our agent program written in Go will be able to read the BPF map and from that update Prometheus metrics and so on. So to distinguish a successful connection and failed connection, I mentioned looking inside the packet to see if there is a TCP RST packet, for example. So that's one side. The other side is we can categorize connections after a timeout. If nothing happened for the connection for a while, if, for example, we only see the TCP SYN packet and then nothing else for more than 20 seconds, in this project we consider that as a failed connection. Or if it is an established connection, we have seen the SNI packet and there is traffic going on after 20 seconds, we don't need to monitor it anymore. We consider it's a successful connection. That was our criteria in this project. And then once we categorize connection, we can annotate the timeline. We have a time bucket here. Every second we annotate it either successful second or failed second. So when all the connections on that second are successful in green, the second is successful. Otherwise, it's in red, it's failed. And some seconds, there are no connections. So in this case, we call it an inactive second, and we just carry on the state from the previous second, like in this example here. This program has two eBPF maps, this kind of global variable I mentioned before. One is called the connections map. We keep track of the connections. That's necessary because BPF programs by themselves, they don't have any state. So we need to keep the states about connection in a BPF map. And we keep, it's a hash table, we keep the tuple of the connection and we keep some statistics about that, whether we have seen the SNI packet or not, on the timestamp and so on. And from that, we can look if the connection has been going on for more than 20 seconds, we are able to categorize it. Another map we have is the statistics. BPF, in this case, keep tracks of the last 20 seconds, and for each slot, we keep a hash table for each SNI, whether there was a successful connection or failed connections. And then the program will be, the Golang program will be able to look at this map and update the metrics. I will not go into that, but that's just to show you the flow of the flow of the execution of the eBPF program for one packet. It will look at inside the packet if it is a TCP SYN and so on, and then update the maps. And similarly, the user space program in Go will look at the maps every second and update the Prometheus metrics. So this project, Connectivity Exporter, can be installed either on the shoot cluster or on the seed cluster, as Wesley explained before. Both cases has pros and cons, depending on what you want to do. If you install it on the shoot clusters, you will be able to notice more error case. For example, if there is a network failure between the two clusters, you are not going to notice that if the component monitoring it is on the server side. So you can catch more things. But it has advantage to install it on the seed cluster as well, like Gardener does. because we are going to notice anyway when the API server is done, when the pod has shut down, you are going to notice that. And you can either see which of the worker node on the seed cluster has a problem. If it is installed here, you cannot see that. So we are able to have a granularity of 1 second to know how many seconds are okay or not. How does it work? Because Prometheus is not scraping the endpoints every second. That will be too much traffic. Typically, Prometheus scraps the endpoint every minute. But what we export is actually a counter of seconds successful or fail. And in Prometheus, the counters are always increasing. So we don't lose the previous second. We can keep the granularity of 1 second. And then Prometheus scraps the different worker nodes. And by looking at the different results, it's able to infer how many seconds are okay or not. This is an example of SNI packet with a Wireshark. This is just to show you that inside the packet you have the IP, TCP, and TLS content, and the SNI name indication extension. It's here, and you can see the name in clear text. And that's what the eBPF program is doing. It's just looking at this packet, and here you can see the C code that look at, for example, the encryption method and so on, and then it go to each field to find the correct field we care about, the SNI packet. So this project has been developed for Gardener initially, but that's an open source project. It's not specific to Gardener. It can work on other Kubernetes distributions. And Wesley has tested it on Gardener. It works, of course. I've tested it on AKS. It works there as well. And you can either test it if you control the control plane, the cluster that contain your API servers. You can try it there as well. It works on Gardener, and I'm exploring the possibility to use that on AKS as well. And for this project, we have written an eBPF program that parse the SNI packet. This can be used for other projects, and this is an example Inspector Gadget. It's an open source project I'm working on to inspect what's happening on the Kubernetes cluster. And we reuse the eBPF program to be able to trace that. So in this example, at the bottom, we have a simple wget command to connect to some server, to Wikipedia. And then here we see Inspector Gadget is able to trace that and notice the SNI packet in real time. Thank you. So if you're interested by this project, you can look at the repository, of course. That's an open source project. And we have some minutes for questions. So a special thanks to Isvan for driving this and helping with the presentation as well, who is not here today.
I missed the part where Gardener basically creates a cluster. Is it specific distribution, Gardener, or he creates EKS, AKS, GKE, or other public clusters?
No, it creates its own. So it's not a specific distribution. It just creates a vanilla Kubernetes cluster. It doesn't create an AKS or EKS
And
cluster.
the ABI server, wasn't it a static bot?
Sorry?
Because you killed an ABI server as a bot.
Yeah.
It was not static bot?
It was not what? Sorry.
A static bot, because if you kill, usually.
Yeah, it's a deployment. So we have so Gardener has lots of different controllers running, and we create like a shoot manifest. So it's just we use Kubernetes to create Kubernetes clusters. So in essence, you create like a shoot manifest, and then we have some controllers that pick that up, and then there's also we have like other controllers running and making sure that the control plane's there, for example, the etcd and the API servers, and we create like deployments or stateful sets for those components.
Okay, and for the daemon set, it's always on the worker nodes, yes? In case of that you're going to monitor a managed public node, managed public distribution like EKS or something like this. So the daemon set will always work on the worker nodes, correct?
Correct. I will open up this picture again. So or maybe I'll open up this. Yeah. So the daemon set is running in the. Yeah, the daemon set is running in the seed cluster here. So this is also a Kubernetes cluster that we also created, and the daemon set is running on those worker nodes of the seed cluster, and the seed cluster hosts the control planes of other Kubernetes clusters. So it's a little bit like an inception model, kind of. So it's like Kubernetes, using Kubernetes to manage Kubernetes.
No, for the case of Alban that mentioned at the end, if you want to use it with AKS or EKS, so basically, how are you going to do that?
You mean this picture here, this one? So if we have the connectivity exporter deployed here, yeah, this is running on all of the worker nodes, and then we can also capture if there's if one of these connections fail for whatever reason, could be because there's a problem here in the internet or a problem on the seed cluster side. Doesn't really matter. Then you can capture all of those failures as well, and those are running on the worker nodes. Yeah, these shoot clusters only have worker nodes, and it's running on all of them.
Hi, a really interesting presentation on both the infrastructure and monitoring side. I was really curious about how we're talking about how there's overhead, right, to monitoring the API server every second, maybe via normal protocols like HTTP and gRPC. And then here, we're kind of sort of like outside of the user space part of the API server process because you're just looking at the TCP connection underneath and like inspecting the TLS, the state of the TLS packets, or the TLS session. And I'm kind of curious, how can we like understand how much overhead that gets rid of, right? Like updating the eBPF map and then having like a Go user space program that's like kind of reading the map every second. Like you're outside of the API server now and you're like in the infrastructure, like inside of instrumenting the kernel. Like how much better is that?
Take that.
Yes. Sorry, I don't remember the numbers. We had made some measurement before, but how to measure them? So there is the user space program we can measure using usual tools, but for the eBPF program is not accounted in the process that manage them because that can run in different contexts in the kernel. And for that, what we have done initially is to take a timestamp in nanoseconds before the execution at the end and make the difference. That's a bit imperfect, but now in the new kernel, there is a better method to, the kernel can automatically track the time spanned by each eBPF program. And we have not done that yet, but we can do that as well.
Cool. And then I am curious about, with like all of this engineering work to monitor in such a different way, what sort of order of magnitude of improvement is there? It's also just probably more reliable, but I'm like, how much of an improvement is this?
I could compare maybe to the previous version. Before doing this with eBPF, there was a previous version done with TCP dump. So it was capturing packets, sending them to user space, and then we can do the same thing in user space.
Yeah.
That's a lot more effort because of the communication between kernel and user space.
Mm-hmm.
With this, we don't have that. All the work is done in kernel, so there is no transition. And this only when we want to look at the maps every second, it's quite fast. It's just a system call to look at the maps.
Because it's just a counter. You're not like passing the packets back and forth. It's just a number.
Exactly,
okay.
yes.
Yeah, so much better I/O. Thank you.
Thanks. I see we have 1 minute left. If there is a last question. If not, thank you.
Thank you very much.
No, I'm saying that the interviews is better, I guess, in the evening. Hopefully finish so that people have when to talk and they have a better opinion. And there's a 15-minute break. What's that? Yeah. After this one, there is a 15-minute break. Okay. Whatever.
mic. Yeah.
Hello. No. Thank you.
Please.
Yeah, so hello everyone. It's been a long time I have given a talk in person, but let's start. So today this talk is about automating updating the non-conformants. And what I mean by non-conformant is, suppose you want to set or a lot of policies in your environment, and you have some resources which are not complying to it and which are not following the policies. Then we are calling that non-conformance. And so the use case we are going to talk about today is, for example, you have a lot of clusters or you have a single cluster, and you want to know which resource is created by who, because your user can create a lot of resources and you'll not know who has created what, and you will be in chaos of resources. And for organizations, security and generally managing image pool policies or setting up your security context, you need policies. And instead of relying on your users to set up everything or be complying to your policies, you can just automate everything using OPA, which is Open Policy Agent, which we are going to talk about today, and also the Gatekeeper, which is the Kubernetes policy controller. So let's move forward. So I'm Harshita Sharma. I work in Kubernetes. I'm a software developer. And I've been working in open source since around 2-3 years. I have worked in various open source projects like managing stateful applications, storage, or managing multi-cluster stack environments, or creating controllers for managing the policies, etc. So the agenda for today is a brief introduction of Open Policy Agent. And so let me ask you guys, who knows about what is OPA? What is Open Policy Agent? Cool, many of you know about it. So, and who knows about the Kubernetes native side of it, which is Gatekeeper? One person. So I'll be explaining it a bit more today. And then what we are going to talk about is, so KKP is a Kubernetes platform, which is a kind of a one-point solution for managing a lot of clusters across cloud on hybrid or edge environment or your cloud environments. And so I'll give a brief introduction of what is KKP, but we'll focus more about how we are managing or automating the policy informants and compliance across cluster stack using KKP. And then mutation, so not just creating the policies, and it's now also about how can you update the resources created or before the resources created. So you can just update the request which goes to the admission controller. Yeah, so as I was saying, we cannot rely on users sometimes to comply with the policy. So it's better if you want to make the policies consistent across your cluster stack, you have some automated platforms already there. So OPA is a policy engine, and what I like what I like about OPA, or why I'm talking about it, is because it's open source firstly, and second is it's now an incubation project in CNCF, so it's highly supported and a lot of contributors from the community side. And we don't need to write code for this because, when we want to apply some policies, and so Kubernetes a few years back removed the policy validation side from the API server, and so now coders can create the admission controllers, write their own code in Golang or Python, whatever. But if you don't want to write the code and if you want a simple solution, then OPA is there for you. There's Rego language, which you need to learn a bit to deal with OPA, but it's quite easy. And if you don't want to learn that too, there are also KKP automation platforms which you can use. So yeah, it's a declarative policy, so declaration is always there when it comes to Kubernetes. Okay, so Gatekeeper. So this is the policy controller, which is Kubernetes native. And the policies which we create are created as CRDs, so it's easily manageable. You can write controllers around it, you can manage it. And it has a rich library, so you don't need to worry about creating your own libraries for policies. So let me define two main terms which we are going to use today, and which are the CRDs of the Gatekeeper. First is constraint, which is our actual policy, which is created by the user, and the constraint templates, which is basically defining the spec of how the policies are going to look, which is usually handled by the admin side of the cluster. And it also has audit functionalities. You can also see the violations which are happening. You can also test it using different modes like dry run if you don't want to enforce it directly. So let's move forward. Okay, so constraint template, this is how it looks like a bit. And the thing you see down there, there we are defining, for example, if you want labels on your resources, and a label can be maybe the owner name who has created the resource, then you can define this, and you can set what happens if the label is missing. So basically, if the label is missing, then you can just show a violation message, which is called you must provide the labels. And there you can see open API v3 schema where we are defining how the label should look like. So basically, it's a composite value, and we have strings over it. So let's move forward. So as we now have seen how constraint template look like, this is actual policy created by the user, and it is saying that whatever namespace are going to create in our cluster should have a label called owner. Otherwise, depending on the enforcement policy, the resource will not be created if the enforcement policy is deny, or if you want to just test it, you can put it to dry run. So let me explain a bit about what are the enforcement actions are. So by default, we have deny. So what does that mean? That if you have created a resource and you have set up a policy that should have a label owner, and if you create a namespace, if we don't have the label, it will just deny your request and the resource will not be created. But if you want to if you have a production environment and you want to check how it works or how the policies will affect your environment, you can just set the enforcement action to dry run, and you can see the violations in the status spec, in the status side of the constraint. And warn is a third enforcement action. It is kind of similar to dry run, but it shows immediate feedback. For example, if you do kubectl create a namespace demo, then it will immediately show you that that you don't have the label owner, but it will not deny the request. It will let the resource to be created. So this is how a gatekeeper handles the violations. Let's move forward. Okay. So for example, as we are asking for, as we have set up the policy that the namespace should have a label owner, but we want to exempt some of the namespaces, maybe Cube system or the namespaces which are handling the control plane pods. So you can do that in multiple ways, depends on the scope of it. For example, you want to set up a global space, you can create a gatekeeper config and just list the number, list or name the namespace you want to exempt from it. And suppose you want to do it on the constraint side, then in the constraint you can add the exempt namespace and a composite literal, and you can list the namespaces you want to exempt from the policy. Third option is adding the exempt namespace flag and the admission gatekeeper flag in the namespace. But how is it different? The second option is the gatekeeper webhook will not be called at all. So you don't want, so it will just, so for example, the gatekeeper is down. So in this case, the second case, there will be no problem because the webhook is not being called. And you can use asterisks if you want to specify the namespaces. For example, for Cube system, you can use cube hyphen asterisk to exempt the Cube system namespace. Now, KKP, Kubernetes platform, which is an automated solution for managing your clusters across cloud, and it manages the whole life cycle of it, creation, management across cloud, AWS, GCP, Azure, whatever you want, and you can handle it or manage it using the UI, the KKP UI. And so today, I'm going to explain a bit about how we have created a solution to manage the policies across the cluster stack in KKP. So this is a bit about KKP. We can automate operations in the cloud native area. We can manage a lot of clusters. We separate the control plane side from the actual user cluster management, so that the user is only need to worry about deploying the applications, and don't need to worry about how the cluster is managed, how the control planes are managed, how the replication is working. So everything is handled by KKP. So this is the architecture, but let me just make it simple for you people. So on the first level, it's called a master cluster, and it has all the control level components of the resources you are going to create and the KKP control components. And then you have a seed cluster, which actually holds the control plane components of the user cluster. So for example, you create a user cluster, and a namespace will be created in a seed cluster, which will have your API server, your control manager, and everything. So we separate the control plane components from the actual user cluster, so that KKP can take care of all the control components, and the user just need to take care about their applications. And what is mentioned here is, suppose, so what this solution helps is, suppose you have 100 clusters, so, and you want to set up a single policy across all of them. What you are going to do? Are you going to go to each and every cluster and create the policies and set up the gatekeeper? That's a pretty hectic solution. So what this does is, on the upper level, which is master cluster, you can just create, the admin can create the template and a constraint, and what will happen is, it will be synced to the seed cluster and then to all the user clusters, depending on if you want to filter the user clusters based on maybe the provider. So you only want the policy to be synced to AWS provided clusters, then you can do that using the filter, or maybe you want to filter using the label. So you can sync, so the controller will sync all the constraints depending on your filters to all the user clusters. So you don't need to worry about going to each and every cluster and creating your policies. And let's move forward. Okay, so this is the basic design of the solution. Templates are created and handled by the admin so that admin can define what policies we are going to set for the organization. And then KKP creates a wrapper around it, the seed constraint template and constraint in the master and seed environment so that it can easily sync and handle it. But on the user cluster side, it's same as how the gatekeeper CRD looks like for constraint template. Okay. And the second thing which is important to discuss today is default constraints. What does this mean is the admin want to set up a single security policy, maybe, for example, setting the security context privilege to false in all the clusters. So the admin can create a policy in master cluster using the UI or the CLI, and it will be synced to all the OPA enabled user clusters based on the filters. So if you want to filter based on the provider or the label, you can filter it, but the policy will be, the default constraint policy will be enforced on all the user clusters. And yep, so let's move forward. So let me show you a bit of the UI, KKP UI, so you have an idea of what it looks like. So here is it. Let's see. So as I told you, admin handles constraint templates and the constraints. So you can see I have already created a constraint template, which is called KTS required labels, which means we are, this is about the organization wants a set of labels to be created or to be set in the resources created. So the template is already there, and I have created a default constraint too. So as you can see, the name is required labels, but the match, which means it will be enforced on the namespace. So the object we want to apply the policy to is namespace, and this is something which is KKP level feature, which is if you want to apply the policies only to AWS provider clusters, and the clusters which have label which is filtered true, then the policy will only be synced to the user clusters which have these, which satisfy this criteria. And you can see here that we can on and off the constraint, which means if you off or you should switch it off, it will be removed from the user clusters. And so, for example, you're testing something in your production environment, or you want to temporarily don't want the policies to be enforced, you can then switch it off, and the policies will be removed, the constraints will be removed from the user clusters. And if you want to set it up again, you can just switch it on through the UI or the CLI, and then it will be synced again to the user clusters. Yeah. So you can add more, if you are an admin, you can add more default constraints, you can add more constraint templates. So all this is handled by the admin. Now let's go to the user clusters. I have created a cluster already, and as we discussed, as I mentioned that it will only be synced, the policy will only be synced to the provider AWS, and which has the labeled filtered true. So let's see if we have the constraint here. So you can see it is synced to this user cluster, and if you have 3 clusters with the same label and the provider, it will be synced to all the 3 clusters. And you can see that, oh, it already has some violations. Let's see what it is. So as I'm not exempted any namespace, it will show that already created namespace, these don't have the label owner. So and then you can see the enforcement action is deny, which means if I create a new namespace which don't have the label owner, it will not be created. And you can see this label here, which means this constraint is created by the admin, and you as a user cannot delete it or edit it. But if you are a user of this cluster, you have access to this cluster, you want to create a constraint only for this cluster, you can add it here, and it will be only applied to this cluster. So you can create a constraint or set up a policy on the cluster stack, or on the cluster level, whatever you wish for. And you can filter your clusters using a label and provider. Okay, let's see if we can go to the cluster now and see what are this there. Okay, so this is the cluster I've already created, and let me check. All right, so let's see if we have the constraint template here. Okay, so we can see there's a constraint here, and let us try to create a new namespace. Maybe demo. So you can see the request is denied because the enforcement action was set as deny. And it's saying that, as mentioned in the constraint template, that the message, if there's a missing label, the message will be you must provide the label's owner. Let's do one thing now. Let's try to edit this and see if we can play with this. I'm going to edit the constraint here. You can see the total violations. You can see all these violations in the status. You can also see it in the KKP UI, wherever you wish for, and you can see the label owner value, and let's see, where is our enforcement action? So it is set as deny. Cool. So let's do one thing. Enforcement action set as try run. All right, enforcement action set as try run now. Let's see if it works. Cool. Let's now try to create another namespace. Maybe test. So you can see, because we have changed the enforcement action, it is now created, though it doesn't have the label, because this is just for the use cases where you don't want to actually, you want the admission webhook to reject your request. You just want to check if it's working or not. And if you want to check the violations, you can again go to the constraint, and you can see that there must be a, yeah. So you can see that the violation is here, but the request will not be denied. And you can, if you want, if you are done with your testing, then you can again change this to deny, and it will be applied again. Let's move on. All right. All right, so why this is useful is for a number of clusters. If, it will save you from the hassle of setting up your gatekeeper and setting up the policies and managing everything. You can simply go to the UI, create your clusters. Your admin can set up the constraint templates, maybe create some constraints that the admin want to be synced to all of the clusters based on the filters. And then you can just manage everything through the UI or the CLI, and it will be applied. Okay, so let's move on to mutation. So till now, the gatekeeper was, till a few years back, it was just allowing you to set up the policies and denying the request if you don't want it. But now you can modify the resources too. And let's see how it does it. There are 3 CRDs mainly. First is assign metadata, which is when you want the mutation or the changes to happen on the resources on the metadata side. But the thing to notice or note here is metadata is not something you can change, you should change without being careful about it. So the only changes you can apply through the mutation, configurable mutation is on the labels and the annotations. And you can add it, but you cannot remove it. And for the spec side, we have another CRD, and all these CRDs are called mutators. And for the assign CRD, we can, if you want to maybe modify the resource for the security context or the image pull policy, you can do it through the assign CRD. And the modify set, which is the third one, this can be used if you want to add or remove argument from the container, then this is this CRD which you can use. So we have three. First is for metadata, only for metadata. Second is for spec side, and third is for adding, removing, or dealing with the argument list or from a spec side list of your containers. And so there are three different sections mostly common in all these CRDs, which is first where you want or which resources you want to change. Second one is the path. So for example, you want to modify the label. So the path would be metadata.labels. And the third is conditions, which is actually what value do you want to change. So you can specify the location plus the value. For example, you want owner label value to be admin. So you can set it in the third part. And there is a match section. So for example, you want to filter changes to be applied based on namespaces or label selector or labels. So for example, you want the changes only to be, or the resources only to be modified in a particular namespace. You can add the namespace in the match section and just add the value of the namespace. And the modifying of the resources will only happen in the resources inside the namespace. And for example, you want to exclude some namespace. For example, you don't want the webhook to modify resources in your kube system namespace. Then you can exclude the namespaces and using this excluded namespace. And if you want to use a label selector, then you can use this. And if you want to specify the scope of it, for example, you want resources to be handled only in the namespace side, then you can specify it here. Okay, so as I mentioned, the location and the value. So the location is specified the path, for example, parameters.assign.val, for example, metadata.labels, and then to assign the value, you have parameters.assign.value, where you can set the values of your label or whatever changes you want in the resource. So this will explain a bit more what I was explaining about location and parameters. So as we were already handling with the policies which want a particular label in the on the resource, so this is what we can create. And as you can see, it deals with the label annotation side of it. So we are not messing with the name or namespace, or we cannot change the name or namespace of our resource using this metadata. So we can only deal with annotations and labels. As you can see here, we can specify what resource you want to be modified. So here it is pod, which is namespace, and the location. So where you want to make the changes. So this is annotation, and the annotation name is owner. So you want the owner annotation of a pod, which is namespace, to be set a value which is admin. Then you can create this CRD. And as I mentioned already, pre-existing labels and annotations cannot be modified because we want to be, or gatekeeper want it to be secure, and not modifying a resource should not cause any chaos in the cluster. So there are some restrictions when it comes to this. For example, you cannot modify already added labels and annotations, but you can add new ones. And let's see how assign works. So this is pretty useful because if you want all your pods to have an image pool policy always, then you can use this. And as I mentioned, you can exclude some namespaces. So here it is system. You can mention a lot of, you can mention, because it's a composite value, you can mention a number of namespaces you want to exempt this mutation from. And the second one is security context. If you want your pod to have a security context value privileged to false, this is important when you want to secure your pods and you don't want your pods to have a lot of access. So you can just create these CRDs, and the resources created will be modified during the time of creation. And this is very important, and it is very useful when you want to set pod affinity and anti-affinity rules. You can actually dynamically take the value of your labels or annotations from the metadata. So for example, you have set a number of nodes, and you want to have a specific number of replication of your etcd pod, and so you can use this CRD, and you can use the label of those pod as the deployment name. So what will happen is no two pods with the same label, no two pods of the same deployable will be created in the same node. So you can use this for pod anti-affinity or pod affinity use cases. And yeah, that's it. Any questions? Yeah.
Thank you for your presentation, very interesting. So I was wondering about constraints templates. So from what I understood, they are created in master cluster, right?
Yeah.
And is the constraint templates synced to the seed cluster?
Right.
So what happens if the user deletes constraint template in the seed cluster? Is it created again by the controller, or?
Yes, yes. So if for example, admin creates a constraint template in master cluster. It will be first synced to seed cluster, and it will be then synced to all the user clusters which are OPA enabled and which satisfy the filters. And in case you delete something in the seed cluster or the user clusters, but because it's still there in the master cluster, it will be again synced through the controller.
So the sync itself is actually really like one directional, right?
Yes, true.
Okay, thank you.
Yeah.
Thank you. Just a kind of a dumb question. What's the difference between the seed cluster and the user cluster?
Okay, so the user cluster are the actual clusters created by the user or an organization where the applications are deployed, where the businesses deploy the application. But the seed cluster is a cluster where we keep, or the KKP keeps, the control plane components of the user cluster. So we separate the control plane from the data plane so that KKP can easily manage everything on the seed side, and user don't need to worry about the managing part of it. And you can just go to your user cluster and start creating your applications, but the management will be handled by the KKP.
Okay, but the master, the master cluster could keep...
So master is something we can use to have all the KKP components plus managing the seed clusters. So it's a hierarchy level. So first is master, managing everything, seed clusters and KKP components, and seeds are actually also defined for the data centers. For example, you are creating your user cluster in a Europe data center of AWS. So based on that, it will be created in a seed cluster, and the seed will have the namespace of that cluster and will have the control components of it, and will have the controllers managing the user cluster, and the user cluster will only have you can deploy your applications, you can manage it. Yeah.
Got it. Okay, thank you.
Okay.
Thanks so much, Harshita.
Thank
Do
you
have any
so
more
much.
questions?
I'm pretty.
sopas en el aire divisó un ángel que le decía, ha nacido el Redentor. De oriente saliente reyes para adorar al Dios niño, y una estrella le guiaba para seguir su camino.
I start. For me, this is my first in-person conference since the pandemic started, so I wanted to see a show of hands for how many of you this is the first in-person conference since COVID. Literally everyone except for one person, I think. Cool. All right, awesome. So I just got a last-minute notice yesterday from Chris that there was an opening, so I jumped in and quickly prepared this talk. So if you have any questions, please feel free to ask them, but after the talk, and I'll be more than happy to talk you through anything that's maybe unclear. And yeah, I'll stick around, so if you see me, just grab me. I'm always available for a chat. So yeah, why did continuous profiling need a new database? That's what I wanted to talk about today. And before I even jump into the database part, I want to clarify what continuous profiling is, because I think it's still kind of an up-and-coming thing. But before we talk about continuous profiling, let's actually just talk about profiling. So profiling is kind of as old as programming itself. So when we did our research, we found that there were profilers literally written in the 1960s and 1970s, basically whenever software engineering started to become like a widely adopted profession. Because ever since programming was a thing, we needed to understand where were resources being spent, where am I spending my CPU, where am I spending my memory, and so on, right? It can really be applied to any resource or anything that you can quantify. And the way that profiling data is typically represented is that we have a stack trace. So here I'm slightly simplifying, but basically we have our stack of functions, right? So main, function 1, function 2, main calling function 1 calling function 2, and we saw this function being 2 seconds being spent in this function, right? And with this kind of data, we can then create statistics that are helpful for us humans to understand where our resources being spent, where can I kind of take an action and improve my program. And so in this kind of very simplified example, we've got 80% of our time being spent in function 3 and 20% being spent in function 2. And all of them are being called from main and function 1. So clearly, function 3 is the thing that we should have a look at to potentially optimize. And continuous profiling is kind of taking profiling, which is typically done on kind of an on-demand basis, right? We take a profile of our program over a 10-second period of time, for example, and that's kind of it. And we have a representation of our program and what our program is doing over those exact 10 seconds in time. And that's great if those 10 seconds are actually representative for your entire program, right? And continuous profiling kind of takes the same kind of approach where that monitoring did, like in the end of the 2000s, beginning of the 2010s, where we went from doing checks, right, like Nagios checks, if you maybe remember that, where we took that and made it into time series. So we have data that we're collecting over time, and then we can do much more sophisticated alerting. If you're maybe familiar with Prometheus, that's exactly what Prometheus is doing, alerting on time series data. And continuous profiling is basically applying that same methodology that we can continuously collect profiling data throughout time. And this was kind of first described by Google in a paper that was published around 2010. And they described how they were always profiling their entire infrastructure, all their data centers, all the time. And it's kind of a classic data problem where if you don't have the data, you don't know what to do, right? Like that's kind of, doesn't just apply to monitoring or observability, it kind of applies to anything. If you don't have data, you're just kind of poking in the dark. And so yeah, the point of continuous profiling is that we don't only have this snapshot of one point in time, but that we have representative data throughout time. And that means when we have that kind of data and we optimize based on that data, we're actually optimizing our process for the entire lifetime of the process, as opposed to just that one little glimpse that we got. So we looked at profiling data. Now, what does continuous profiling data kind of in theory look like, right? We still have our stack traces, and then we have what we added essentially is the time axis, right? So not only do we have one point in time, but we're looking at multiple points in time, and where kind of the measurements that are happening there. And one, like, obviously this is made up data, excuse me, but something that you can already see is that obviously because of how programs work, we're not always observing the same stack traces. We're not even seeing anything, the data is not even similar necessarily across points in time. And that's why continuous profiling is important, so that we get a statistically sound representation of our program over all of time. And so that's why individual profiles are actually comparatively uninteresting. I'm just going to cycle through a couple of kind of data points, and we'll kind of have a demo later. But these individually kind of are sort of boring, and they're not particularly representative over the entire point in time. We can see, right, like the CPU time keeps jumping, and it keeps doing different things, because that's just what programs do, right? But the point is, when we take all of this data and now combine it into a single representation, now this is actually representative of our program throughout time, right? If I'm able to optimize something in this entire stack, it means I'm actually optimizing like 50% of my CPU time that is being spent in my entire data center, right? So what we're looking at here is not just profiling data of a single process, but profiling data of all processes in all my data centers combined, right? So this is actually something that helps us save cost, because we have something that's statistically significant in terms of the CPU time that's being spent. And at this point, you know, people start saying, okay, all of this sounds pretty great, but whenever I think of profiling, I think of super high overhead, like a super high overhead thing, and that's why we only do it on demand. And that's not wrong, but there are a couple of tricks that we can apply to make it super low overhead. And most of the time, at least with CPU profilers, we do something called sampling profiling. So in theory, the way we can think about it is we look X amount of times per second, we look at the current stack, right? And based on that, we can kind of infer, because we know which functions are in that stack trace at that point in time, we can infer how much time is being spent, right? It's all statistics. And because it's sampling, we can control the sampling rate, how often we're actually looking at it. And depending on how high that frequency is, that's how much overhead we incur. And so what we're working on essentially ended up being a profiler that has about 1% in overhead. But we find that most organizations are able to easily optimize 20 to 30% of their CPU time. So, you know, go figure, that definitely makes sense for most organizations to do. But, you know, this is not, it's easy to put this on a slide. This is very, very difficult engineering work. And in part, the way we make this work, and there are many other talks about this, but the way we make this work essentially is using eBPF to collect this data and kind of really only collecting the data we truly need in kernel space, kind of aggregating it there, and then only every 10 seconds actually grabbing this data. And that's how we're effectively able to do this at super low overhead. Now, I kind of, so far, only talked about continuous profiling data as in profiling data over time, right? Something that we wanted to do is that we can aggregate profiling data across any axis. If you're familiar with Prometheus, this probably looks very familiar. So we have kind of a query language where we first differentiate in the type of profile that we're looking for, and then we can have arbitrary labels that kind of slice and dice our infrastructure. So region is an interesting one, or it can be anything. Maybe in Kubernetes, it's namespace, pod, container, node, anything that's useful to you and how you and your organization organize your infrastructure is completely configurable. Now, again, in theory, this is really nice, and it's nice to say this, right? But this takes a lot of engineering effort to make this work. And I just want to show you a very quick demo that this does actually work. So we have a demo instance on demo.parka.dev where you can try this out. So we have some profiling data here. Bigger, sorry about that. Can people in the back see that as well? OK, so basically what I did is I selected I want to see CPU samples, and I hit search, and now we can see kind of the CPU time that's being spent over time. And we can click an individual sample, and we'll get the flame graph for that particular point in time. And as I said, we can kind of slice and dice this. So if we just wanted to see the Parka container, for example, or if we just want to see a particular area, or we can kind of dive in and find exactly the data that we're looking for. We can slice and dice it by the container, by the labels, and then finally we can actually also merge all of this data across time, right? So what we're now looking at is not just a point in time of the container, but the entire CPU time that was being spent throughout this time frame, right? And I won't go into too much more detail, but there's lots of other features where we can kind of compare different points in time. So I can click this sample, whoops, and this sample, and then we should see the difference. Well, maybe it'll still load, but essentially what we should be seeing is a flame graph that looks kind of similar to what we had before, but it is colored, indicating whether something got better or worse, right? So green indicating that I'm spending less CPU time somewhere, red, and depending on the shade of red, kind of how much worse it got. Maybe we can try this again later. Maybe we got more luck with the demo gods then. But yeah, that's kind of the point of why we want to do continuous profiling. There's so much possibility, and I won't dive into too many things, but the thing that I wanted to show at the end, comparing is super interesting when you, for example, roll out a new version of software, right? You kind of all of a sudden have a surge in latency or something, and you want to know why, right? Previously, maybe we looked at the Git diff, and we can maybe try to understand what's happening, but with this, we actually down to the line number can tell you where things got worse, right, with statistic significance. And so just kind of doing a back of the envelope math, and I won't go through all of these numbers in particular, but if we're looking at 100 stacks per second, and that's per host that we're looking at, then we're talking about if we're looking at 1,000 hosts, relatively large Kubernetes cluster, but definitely the kind of size that we want to be able to deal with. Then we're dealing with 10 billion samples per day that we want to be able to slice and dice on any dimension at reasonable latency. So this is a pretty difficult data problem to solve, to do at kind of real time. So when we kind of started to work on this, we did a bunch of experiments with existing databases, And we wrote an entire blog post with all of the kind of things that we explored and all of the things we failed at. So if you're interested in all of that, go to our blog. Here I'll just kind of talk you through the thing that actually ended up working for us. And what we ended up going with is a columnar database. And as the talk title suggested, we actually built one ourselves. So let's go kind of and look at the problem that we're trying to solve if we think about all of this data as tabular data. So we have our labels that are dynamic, right? We don't necessarily know the labels that are going to occur up front. That just needs to happen as the labels trickle in. And the rest is kind of the same as we were looking at before. We have our stack traces, we have our timestamps, and the values, kind of the occurrences. How often have we seen the stack trace at this timestamp? So that was just the logical layout. And the reason why for us a columnar layout actually ended up working out super well is because we can kind of exploit the locality of data being stored by columns rather than by rows. So that's essentially what makes a columnar database. Typically, most relational databases, they store all of the data belonging to a row physically on disk together. In a columnar database, we store all of the data points of a column all after each other. And so CPUs are particularly good at sequentially kind of working through data that has cache locality, right? Like basically the CPU ends up loading a bunch of these things at once into CPU cache and then can immediately kind of process that. And there's a bunch of CPU tricks that you can apply to these with a characteristic like that. So for us, that ended up working out really well, at least in theory. But it took a bunch of really hard work to actually make this work. And once again, we realized that the characteristics of a columnar database were probably going to be really good for us. But of course, I don't know how many people have built a database, but it's hard. It's a lot of work, and ideally we would be focusing on the continuous profiling bits and kind of creating a product rather than creating foundational infrastructure pieces. So we looked at existing columnar databases, but the problem was we had this label data that was variable in their keys, right? We didn't know the kind of keys that were going to occur, and the best kind of data type that existing columnar databases had, we looked at ClickHouse, we looked at DuckDB, we looked at a couple of other ones. The one that came closest for us was InfluxDB IOX. However, unfortunately, we talked to the maintainers, and they said it was not going to be ready for us to be used in time. If you're interested in any of database stuff, absolutely check out InfluxDB IOX. They're doing some really incredible stuff, but just it wasn't going to align with our timeline. But they were super open with their experience, and they shared a bunch of their kind of experiments that they did and directions, and so that informed a lot of our decisions. But basically, the only thing that existing columnar databases had were map types. So we could store the labels as maps, but this had exactly the same problem that we had with a relational database. We need to be able to kind of iterate through this data all at once, right? And if we store a map, we're still going to be loading all of this data, even if we're not interested in it. So even though we're now going into a columnar database, we still would end up with the kind of characteristics of a relational database that is row-based. So that wasn't going to work for us, we realized. And for compression to be optimal, if we go back, kind of looking at this data, we could also, not only could we exploit that this data is kind of all in memory, kind of one after each other, because it's like that, we can kind of exploit repetition and things like that to say things like, okay, I have 6 times the same value coming up now. I have it 2 times, or all of these kinds of things. And there are lots of different kind of compression mechanisms that we can apply here to not only make it fast to be processed at query time, but also efficient to store in memory and on disk. And so we realized after looking around for a very, very long time that we were just going to have to build it. And the first kind of problem, as I said, that absolutely no database out there was going to be able to provide us with is kind of this notion of dynamic columns. Something that kind of has sort of a schema, right? We know that the values of this stuff is going to be strings, but we don't know the actual columns that are going to be needed up front. So it needed to automatically kind of dynamically create them as we see them for the first time. So that was kind of requirement number one. And I was talking about the ability to exploit like repetition and things like that for compression to be optimal. And for that to work, we were going to have to also sort all of our data globally through basically all of the data that we have needs to be sorted so that we can actually reach reasonable compression. And it kind of has an interesting or a really amazing side effect as well. When data is sorted, we won't need an index for all of this data to be able to do a binary search to find the kind of data that we're interested in when we do a query, right? So it has so many benefits that we felt like this was worth investigating how we could do this. So the way that we end up maintaining global sorting in our database is that we have something that we call a granule. And a granule essentially has an upper, a lower, and an upper range, right? And we say everything in this granule is within this range. And so every time we insert new data, we essentially split up the data and we insert it into the appropriate granule. And that's how we globally maintain sorting. And there are a bunch of tricks in here how doing these inserts is actually can be achieved in a cheap way. And it all kind of boils down to that all data is always sorted, whether it's the data that's inserted or the data that's held in memory or the data that's on disk. Just kind of the sorting is maintained throughout the entire lifetime of data. And the granule, in order to be able to, I was talking about using binary search to jump to places so that queries could be efficient. In order to kind of maintain that property over time as we insert more and more data, we need to also split these granules so that we continue to have the granularity to jump to actually the right place and not iterate over a bunch of unnecessary data. Because we could start with 4 granules, but that's kind of pointless because we'll end up going into a granule, and then if we have 100 billion samples, then we're still going to end up iterating over 25 billion. So that's not really winning anything. So that's why we needed to create a mechanism to, when we reach a certain granule size, also split it, and then we insert it into this, what we call a sparse index, which essentially only has the upper and lower bounds so that we have a order of magnitude smaller space to search through. And in reality, a granule is actually not sorted in itself, even though I kind of made it look like that, right? I said that 5, 6, 7 here, that these are sorted in themselves, but actually what happens is that we only respect the upper and lower bound, and within that granule, we just keep adding the parts, and eventually when we do the splitting, we actually merge them and put them into the sorted order. And so, eventually everything is actually globally sorted, but it depends on the type of query that we're doing, whether we actually end up sorting it at query time. Because most queries don't actually require sorting, except for when we do you saw earlier we were querying over time, right? That's the kind of query that definitely needs sorting because we as humans want to see the sorted data. But when we were looking at the flame graph, for example, all we're doing is taking all of the values and just kind of crushing them together by stack trace. So that kind of query doesn't require sorting, and yeah. sorting is relatively expensive when you do it over hundreds of billions values. So yeah, and then the very last thing, to make all of this safe, right? Or safety is a spectrum in software engineering, but in order to be able to only see certain pieces of data and don't see like what we call like ripped writes. So what that means is if we insert, let's say, a batch of 10,000 rows, we want to only see all of those rows at once at query time, not maybe 2,000 of those rows. It's a classic kind of database problem that you need to solve so that things like alerting and reporting is actually accurate. Otherwise, you can get confusing data when you insert 10,000 rows and you end up getting 2,000 rows out. So we have a mechanism that ends up giving us snapshot isolation, if you're familiar with the term. But essentially what that means is that at a point in time that you're reading, you're definitely getting a consistent view of the data. And the way that we achieve this, because the database that we wrote is a write-only database, so we can never modify data. That's also particularly important for sorting, right? If we were able to kind of change the value of a label, for example, that would mean that we're now changing the sorting of this row in the data globally, and that's something that cannot happen. And that's why one of the reasons why this database is a write-only database. But essentially what we're doing is we're inserting all of the parts that we saw, right? We have the granules and we have parts in the granule, and the parts themselves have a transaction ID attached to them. And then what we do is we expect all transactions to linearly be made available, and essentially a lower transaction can always block a higher transaction, and only if we make linear progress do we actually make progress. And again, there are a bunch of tricks to actually make this safe, because as you can probably imagine, if we do something like that, that means that if there's one transaction that's forever blocking, it means we'll never make progress. It's one of those things that while theoretically this means that we have snapshot isolation, in practice it doesn't actually work. But the way we make this work is that just every transaction has a timeout, and so eventually we'll always make progress. But the point of everything that I said in this slide is that it's safe to read data back from this database if you didn't care about any of the other stuff that I said. So yeah, we built all of this for the open source continuous profiling project that we maintain called Parka, and we just last week released this as part of version 0.11. And yeah, so what's next for all of this? Actually, right now, this database is entirely in memory, although we have a couple of experiments of flushing this data to disk. It's, of course, everyone wants data over time, and we do as well. It's just, the development of a database takes time, and we just haven't gotten to it. And then the kind of next step is that not only do we want to persist it, but we also specifically designed all of this to work super well with object storage. And I could give another talk about why object storage is a good choice here, but essentially it allows us to treat storage as infinite, right? And we made a bunch of design decisions that allows us to optimize this for object storage. So yeah, that's it. Thank you for listening. If you have any questions, I'm be super happy to answer those now, but we also separately open source this database under our Polar Signals org ArcticDB. Yeah, thank you for listening. Questions?
Hello. That 10 billion query you mentioned at the start, what sort of size would that be on disk? What sort of cost might that be in object storage?
So it highly depends on the most expensive part in all of this is the strings, right? So it depends on how many dimensions you have and how big the strings within those dimensions are and how repetitive they are. So it can vary from, a few gigabytes to potentially tens or hundreds of gigabytes. It super highly depends on the variability of the string.
But I suppose gigabytes is the smallest unit of magnitude we're talking about.
That's right, but at the same time, the usefulness increases the higher the higher cardinality you have. So it's a trade-off, and I recommend to kind of play with it and figure out whether you can ask and answer the kind of questions that you're interested in, and potentially add more dimensions if you cannot.
Hi. What is the difference between ArcticDB and the other database you talk about?
Sorry, between ArcticDB and what?
You mentioned another name of database before. No, Porca? Oh.
So the databases that I have mentioned were DuckDB, ClickHouse, IOX. Yeah, that's it. And the open source project that we integrated our database into is Parka. That's the continuous profiling project that I kind of started with that set all of the requirements for us building this database in the first place.
Thank you.
Hi, thanks so much, Frederick.
Thank you.
But let me say one thing. I am a Catalan. Today, a province of Spain. But what has been Catalonia? Catalonia has been the greatest nation in the world. I will tell you why. Catalonia has had the first parliament much before England. Catalonia at the beginning of the United Nations.
Catalonia
All the authorities of Catalonia in the 11th century met in the city of France, at that time Catalonia, to speak about peace. In the 11th century, peace in the world, and against war.
Catalonia Catalonia's Notice Page. Catalonia's Notice Page.
But let me say one thing. I am a Catalan. Today, a province of Spain. But what has been Catalonia?
Catalonia's Notice Page.
I'm a data scientist at BMW, and today I'm going to discuss machine learning as a software architecture for machine learning applications in a production-like environment. That is, regarding machine learning in general, there's no doubt that data pre-processing and the training of AI models are absolutely crucial. However, unless an AI model is deployed and frequently yields results to previously issued inference requests, it just doesn't add any value to an organization, right? So today I focus explicitly on the post-training step, and here we go. The experience we made at BMW is that the migration of AI models from a training laboratory environment to what we call production, so a prediction phase or inference phase, is quite a long way. And to give you an idea what we are up to, so I assembled the most important high-level requirements which are valid for our business context. What we are doing anyway is we have huge fleets of cars, and what we do is we monitor the intercomputer traffic from cars. Doing that, we've got two use cases. So one is if a car is driving, we persist all the network traffics between computers, so we call them ECUs. And once the car's back on its home base, we upload them, and then they are analyzed. And that's what is done in an on-premise cloud environment. However, in a second use case, we can also do the analysis in real time in a car. So everything we do is about development cars under development. And then what we would like to do is to complement our current tool set with the possibility to analyze these intercomputer traffic based on machine learning, based on AI models. So, and also the fleet of cars we are maintaining implies that we want to do remote software updates, like we would like to do updates remotely of the application itself and also of the AI models then. So in order to cope with all these challenges, this is what we use as a tech stack currently. These are all, well, important for us. However, in order to discuss the high-level concepts, the first 2 points from that list are really crucial. That's why I will discuss them in more detail, and the other points from that list we will rather touch on the fly. You could say that for this kind of application, WebAssembly is really at the nucleus. So technically, WebAssembly is about a bytecode instruction format that is designed to be executed on a stack-based machine in a virtual environment. And just in case it reminds you of the Java virtual machine, I think you got a point, because personally I really like to compare the JVM to WebAssembly. If you remember, the JVM once entered the stage with a promise to make it possible writing portable code. Today there are quite a few people saying that finally WebAssembly will deliver what the JVM once promised, but never fully put into reality. So coming back to WebAssembly then, other high-level design goals of WebAssembly are security and speed. And security, for example, if you compile code to what's called and executed as a WebAssembly module, it runs in a sandbox-like environment. And the implications are rather severe that from that safe or secure guest module, you cannot reach and access the host environment. Like you cannot access the host file system, you cannot access host network sockets, you cannot even get the time from a host clock. To put that on a meta level, the characteristic of what and how I perceive WebAssembly is such that it has quite a few well-selected high-level design goals on which it delivers brilliantly. And on the other hand, if you assume or if you expect other concepts which you would assume to be naturally there in any modern software development context, there are just a few which are just out of the scope of WebAssembly. And that's where the next point from our tech stack comes in. So I introduce Wasm Cloud. Firsthand, Wasm Cloud is an open source project under the hood of the Cloud Native Computing Foundation, brief CNCF. In a narrow sense, it is designed to be a Wasm host runtime. That is, it's a runtime where you can execute WebAssembly modules. Well, the ambitions are much broader and higher, so in a broader context, this is about a platform for writing portable and secure business logic and applications, and you can deploy them anywhere. So you can deploy them in a cloud context, on the edge, and even on browsers. And what's pretty interesting from my point of view is the question how Wasm Cloud relates to WebAssembly. And this makes them a very powerful team. So Wasm Cloud takes advantage of the very strong unique selling points of WebAssembly, where concepts are present, and where they are not, it adds, so it complements WebAssembly by other concepts. And to give two examples, so in the documentation of Wasm Cloud, you will almost know here read about WebAssembly modules because they kind of promote the concept of pure WebAssembly modules and render it being an actor. So the term comes from the well-known paradigm of concurrent compute because inherently WebAssembly doesn't have any notion of concurrency, at least not in the main trunk. I think there are proposals today, but so not in the mainstream. And using Wasm Cloud, you get WebAssembly module characteristics plus concurrency. So the other aspect we already addressed, that's you cannot deal with peripherals from within WebAssembly. Wasm Cloud resolves that by just introducing a second type of technical entity called capability provider. And whenever you have to deal with peripherals from your business logic, you can connect to a specific capability provider via well-designed interfaces called contracts, and then you can do whatever you would assume to be doing in a modern software development environment. So now I think we have all the technical ingredients to discuss real-world machine learning applications, and I would like to approach this topic from a rather development perspective. So then at the very heart of such an application is probably what you call an inference engine. In fact, we have two. We currently provide Onyx and TensorFlow, and both reside in a first capability provider. And then on the left hand, you have the endpoint to the application, so that's where you address inference requests to. Currently, that's an HTTP server. You can also secure the communication chain. And in a very trivial use case, then, so you send data, input data to this HTTP server. It's routed to the API actor. That's where you want to define your endpoints. So the API can define REST-like endpoints. You can pre-validate the incoming data, and then it's routed directly to the inference engine. And also the way back, such that the response from the AI model is handed to the user, and then adding value that way. However, in a more general use case, you would like to have additional business logic. And that is because by only using API actors, you have severe requirements for your users. That is, an arbitrary AI model usually expects its input data, well, in a multidimensional data structure called tensor, but where the tensor has very specific dimensions and also other statistical characteristics. So if you do not hand a tensor, the way an AI model requests, it will either not deliver valuable results or not work at all. That's why you want to make use, in a more general case, of a pre- and post-processing step, where such that your users may then send in arbitrary data that is pre-processed, such that it matches the needs of your AI model, and then send back. And before sending back to the user, you want to apply post-processing, because the results are usually not interpretable by human beings. You want to apply some mathematical post-processing. To give an example, so today's application I brought here, this is about image classification. So I have two models with me, on which we'll have a look later on, which are trained on 1,000 classes, and they are designed to recognize classes from images. So classes of objects or animals. What you're going to do, so for example, with the curl command, you can issue your request, and in that example, then we put in an image, and it can be of arbitrary dimensions. So the pre-processing step will make the dimensions match to what the AI model needs. And then the model output, at least in our example, will give you 1,000 scalars. So for each class, against what it has been trained, one number. And only after having applied a softmax function, you can interpret it as a human being, so in terms of probabilities. Now, my proposal is to switch to the demo application. Let's see if that works. Oh, it's pretty small, so maybe I have to describe well what I'm going to do. So we have another image of a whale, and you will not be able to read the dimensions, so it has arbitrary dimensions. The models, however, which I brought today, they need the image dimensions be in 224 by 224. So now, it may be too small, but so just in case you can read it, you will hopefully recognize that curl command. This is a put method. We will send an arbitrary image to that model, and so within the segments of the URL path, you will find the endpoint, so the address of the HTTP server, which I have previously configured for us. Then you need to mention which model you want to use, so that's in the second segment. And the last segment, that is called matches, it tries to make life as easy as it can, so it applies a pre- and a post-processing step such that we can send in arbitrary images and get back results which we can directly interpret as persons. So for example, you've seen the image of that whale. So we see the 5 matches, the top 5 matches of what the model thinks it gets as input. And the first match, so with almost 100% probability, is a gray whale. And without being an expert in biology, I think that, well, it matches quite well. We might want to look at a different example. So I think we also have cats here in our image database. Let's look up the cat. Yeah. So if we look at that before applying that to our machine learning model, I hope you recognize it, and I hope you see the stripes, so the dark stripes. So now if we ask the model to interpret it for us, the top 5 entries are tabby cat, and for all non-native speaker, tabby is tiger-like, and in fact the second position we have a tiger cat, so it thinks that we have a tiger cat in our image. And well, only at the 5th position it thinks that this might as well be a paper towel, but note that the probability is really small. So I said that, that's not very well visible. I said that, so in the second segment to the last, you have the model. There are other models we can apply. Let's make a last example. So what we have issued our request against now, this is MobileNet. We also have SqueezeNet. Yeah, I just didn't type it. It doesn't matter. Then we make that example maybe later. So that's the inference pipeline. And now we have the picture from the development perspective. So if we look rather from the operations perspective at the same application, you likely have an empty runtime, that is before deployment, and you have two other technical entities. And that is one model repository and one OCI registry, where OCI is for Open Container Initiative, so you can just take an arbitrary container registry. The model repository we take as a bundle, so the open source project bundle from Dice Labs, and that's where your AI models reside. So probably the data scientists from your department previously have uploaded their trained AI models in there. And in the OCI registry, that's where your capability providers and the actors reside. So when deploying something into your runtime, you will want to select all the items you need for your application, and then by external configuration files, which may easily put into version repositories, you can define your application such that the entities are downloaded from the OCI registry. And once the inference engine is up and running, you do the same with the AI models. So once this is configured, the inference engine will download the AI models into its context, such it can apply and use them. Just in case your application runs bigger, you may want to know what's going on in your application, and that's why Wasm Cloud provides a view, which is not here. So we can make it bigger. So it provides a browser-based UI, and it shows what is called the inventory of any given runtime. I hope you recognize by now the two providers we have deployed. So that's the HTTP server and the inference engine. It's called here ML Inference. And on the left hand, we have our three actors. So that was the API actor, which defines the application's endpoints. And we have a post-processor and a pre-processor. And you also have the host info, so that's the one host which is currently running. And what we didn't discuss so far is all the linked definitions. So I said maybe briefly that if an actor, so your piece of business logic, needs to deal with peripherals, it does so on behalf of a capability provider, and you have to link it explicitly. And by the explicit step of linking, you can provide configuration information. So for example, at the very step, when you link the inference API against the inference engine, you would hand over the models which you want to use in your application. We can briefly look at how that is done in code, maybe. So you maybe recognize the MobileNet v2 model. That's the one we issued our request against. And then I had some typos for the SqueezeNet. This is the second model which is downloaded from the inference engine into its context. And then we have a few just for debugging purposes. But the interesting point to take here from is that this kind of logic is not part of the code base. It's given by external configuration files. And also, what we didn't address so far, if you take the whole setup, I didn't mention yet that the high-level entities, they are currently all deployed on my machine just to show them, to be able to show them easily. They may very well be distributed among different nodes, so maybe also spread geographically. Yeah, I think we have all the aspects we need. That leaves me with some side remarks or final remarks. So the example application we looked at is in that GitHub repository. And in case you are interested, you want to reach out, collaborate, we usually meet in the Wasm Cloud Slack channel. Thank you very much for listening.
Cool talk, thank you. So on the predictions that are produced when on inference, is there some logging or auditing of the quality of those? And is that part of the system as well?
Sorry, I didn't get that. There's some?
So on the predictions that are made by the inferences, are they logged somewhere so that later they can be audited to see how well the model was doing in production?
You mean if we measure metrics?
Yes.
Not so far. I've seen these metrics in other open source products, like from NVIDIA, the Triton server. No, we just started. We do not have them yet. Would be on the roadmap. So speaking about the roadmap, so the very first next thing is to integrate accelerators. That's what we explicitly target next, because for the edge use case, we have to get out of the CPU. So we want the inferencing to be done on accelerators, like we look at the Coral Dev board and its edge TPU, and then metrics will probably come thereafter.
That's good.
Yeah, thank you for the presentation. One question in related to which, so the main driver for you to move to WebAssembly is portability, or there were any other driver? Because we start to see more and more WebAssembly, so what's the compelling event to decide you to move to WebAssembly, because most of this stuff has not been done or is not usually done with WebAssembly.
Thank you. So I understand the question as being, what is the main driver to switch or to look for WebAssembly, right? So here it was rather Wasm Cloud. So we were looking for an environment where, with the same code base, or one and only one code base, we may serve different targets, like a cloud-like environment and an edge-like environment. So these are given constraints from our business context, so to say. And then we came across Wasm Cloud, and it makes very advantageous use of WebAssembly. That's how we came together, these words, and I think they match very well.
Thank you.
Awesome, thanks much.
Catalonia's Notice Page. Catalonia's Notice Page.
But let me say one thing. I am a Catalan. Today, a province of Spain. But what has been Catalonia?
Catalonia's Notice Page. Catalonia's Notice Page.
Catalonia has been the greatest nation in the world. I will tell you why. Catalonia has had the first parliament much before England. Catalonia had the beginning of the United Nations.
Catalonia's Notice Page. Catalonia's Notice Page.
All the authorities of Catalonia in the 11th century met in a city of France, at that time Catalonia, to speak about peace. In the 11th century, peace in the world, and against wars.
Catalonia's Notice Page.
Don't let it rule you. Everything's gonna be alright. Don't let it rule you.
Catalonia's not Spain. Catalonia's not Spain.
But let me say one thing. I am a Catalan. Today, a province of Spain. But what has been Catalonia?
Catalonia's not Spain. Catalonia's not Spain.
Catalonia has been the greatest nation in the world. I will tell you why. Catalonia has had the first parliament much before England. Catalonia had the beginning of the United Nations.
Catalonia's not Spain. Catalonia's not Spain.
All the authorities of Catalonia in the 11th century met in a city of France, at that time Catalonia, to speak about peace. In the 11th century, peace in the world, and against wars.
Catalonia's not Spain.
everything's gonna be alright.
the wrong place to be. I think I should go home, but I don't know where it is. Bring it back to me, please. Bring it back to me, please. Bring it back to me, please. It's making me feel so weak. It's making me feel so weak. Bring it back.
Catalonia's Native Rejekts. Catalonia's Native Rejekts.
But let me say one thing. I am a Catalan. Today, a province of Spain. But what has been Catalonia?
Catalonia's Native Rejekts. Catalonia's Native Rejekts.
Catalonia has been the greatest nation in the world. I will tell you why. Catalonia has had the first parliament much before England. Catalonia had the beginning of the United Nations.
Catalonia is not in Spain. Catalonia is not in Spain.
All the authorities of Catalonia in the 11th century met in a city of France, at that time Catalonia, to speak about peace. In the 11th century, peace in the world, and against wars.
Catalonia is not in Spain. Catalonia is not in Spain.
Get sexy. Dance with me, dance with me. Dance with me, dance with me.
I need you.
Dance with me, dance with me.
I need you.
Dance with me, dance with me. Dance with me, dance with me.
I need you.
Dance with me, dance with me.
I need you.
Dance with me, dance with me. Get sexy.
I need you.
Dance with
say what I mean, and everywhere I go is the wrong place to be. I think I should go home, but I don't know where it is. Bring me back to me. Bring me back to me. Bring me back to me. It's making me feel so weak. It's making me feel so weak. Bring me back.
Don't let it rule you. Everything's gonna be alright. Don't let it rule you.
long lunch break. I hope everybody enjoyed all the local cuisine. The first talk we have is Adrian Moat, Supply Chain Security with Six Store and Kiverno. Yeah, I think I did okay. Yeah, does anybody know? Oh, so success to me. Enjoy the talk.
Let's check this is working. So a little bit of background. I think most people have heard a lot about security in the last, well, few years really. We had like Biden's executive order that, on cybersecurity and supply chain security and software. We had the SolarWinds attack, and I think the SolarWinds attack is still driving a lot of what's going on because that was a very sort of sophisticated attack, and I think other people are aware that they wouldn't have been able to stop it either. We've also had a Log4j nightmare that's rolled on and on. And a lot of these attacks have had to do with dependencies and third-party code we use, or in other words, with our supply chains. And here's a report from Sonatype in 2021. I'm not entirely sure what numbers they're using, but they came up with a 650% year-over-year increase in terms of supply chain attacks, which they've classified here as dependency confusion. So presumably when an attacker gives you perhaps an out-of-date version of a dependency or a malicious version of dependency. Typo squatting, which you probably know, like if you fat finger a dependency, then an attacker can give you perhaps something that looks like it does the same, but also does something malicious behind the scenes, and then simply malicious code injection. There we go. So, if there's one takeaway I'd like you to take from this talk, it would just be to think about these two questions. So, if you're in charge of a Kubernetes cluster, do you know what's running in that cluster? As in, if you look at a kubectl git pods, can you name all the pods? And can you look at them and tell what they are, like what they're running, if it's Nginx, if it's your microservice front end, if it's a Kubernetes system pod? Can you tell who created them? Can you tell if they're out of date? And can you tell exactly which version of the source code there was? So the actual git commit that was used to build them. And perhaps more interestingly, how much of that can you prove? Can you prove that that container is running your code and it hasn't changed since it was built? Or is it possible that somebody's, an attacker is running a different pod with the same name as one of your pods, or somehow tampered with the code on the way to a deployment? And most people struggle to answer those questions, frankly. But one way to get, it is possible to answer those questions definitively, but it's actually really quite hard. But one of the first steps we can take is by signing our images. And this gives us a lot more trust that what we're running is what we think we're running, or came from who we think it came from, at least. So signing the image is pretty simple. It just is about verifying the source of your images. I think most of you are probably roughly aware. It's basically this idea of having a public and private key. We can sign things with a private key. So for example, with images, you can sign the SHA digest of an image. And then other people can use the public key to decrypt that and look at the SHA of the image. And if that SHA matches, then you've now verified that that image was signed by whoever had access to the private part of the key. There is a lot more to security and supply chain security than just signing, but signing is a good start. Other things you can look at, things like reproducibility, running vulnerability scanners, etc. So, how can you sign images? There's two ways roughly at the minute. So there's Notary. Some of you probably remember Notary version 1, which was largely a Docker, or started off as a Docker project. And it was pretty cool. Like, it did all this update framework stuff, But it was also kind of complicated, and a big drawback was you had to like spin up your own notary server, which was, you know, a bit of a pain. So they went back to the drawing board and they come up with Notary V2. I don't really have much updates on that, but I am aware that Microsoft are working on it, so there's probably a few people here that know a lot more about it. You can come and chat with me afterwards. However, what we do have, and what I'm going to talk about today, is SIGSTOR. So SIGSTOR's here and it works, and you can use it today. Rather than store your signatures in a separate service, you just store the signatures alongside the images in the registry, or you can actually store them in a separate registry, but they just become blobs in a normal OCI registry, like the Docker Hub, for example. It is being very rapidly adopted. There's a big milestone the other week where the Kubernetes releases are now signed with SIGSTOR, so that was pretty great. And it is a Linux Foundation project, so the company I work for, ChainGuard, are heavily involved in it, but there's also other people like Red Hat and Google, and I can't name the others, but we'll keep going. Yeah, Kyverno. So just signing things is kind of pointless, right? You have to do something with those signatures for it to be worthwhile. So I'm going to show you a demo. Most of this talk is going to be a demo. And in the demo at the end, what we'll do is we'll use Kyverno to verify that the images inside our cluster are in fact signed. Yeah, Kyverno is a CNCF sandbox project. You can use other solutions. A lot of people use OPA or OPA. We also released a commercial one recently called ChainGuard Enforce that will do like policy enforcement for Kubernetes clusters. And because it's a commercial project, I won't talk any more about that at the minute, though. OK. Now, some of you might be following me on Twitter. I have had like an interest in the last 24 hours, and I've not had much luck. So I suspect this could go horribly wrong, but we're going to try and do a demo anyway. If I can even find a mouse pointer. There we go. So from there, didn't mean to do that. No, that's not a good start. Take this out of full screen, maybe. Why is it not working? I had it. Is it hidden? No, it's on this one. Maybe I'll get rid of it. There we go. It's behind that. OK, here we go. We'll get there. Right, so why didn't that work? Here we go. So the main command that you use to work with SIGSTOR is cosign. SIGSTOR is made up of like 3 sort of projects. There's cosign, Recor, and Fulcio. And I'll explain how they're all related in a minute. But as a developer, the main one you're going to be using is cosign. Is this big enough? Do you want it a bit bigger? Bigger. Is that any better? It's not that much bigger. OK. I'll probably start running out of room soon. Right. So I'll probably let me delete. I did do a run through before, and I've not tidied up because. OK. So. I'm not doing cosine sound, I'm doing cosine generate. Where's my pointer? Oh, come on. Right. So this is a problem with me not mirroring the screens now. Anyway. So there's a generate key pair command, which will unsurprisingly generate public-private key pair, if I spell it correctly, yes. That's not right. And also, the reason I want to show the help was just because you can like ask it to store things and stuff like AWS KMS, Google Cloud KMS, HashiCorp Vault, and so on. So you can store your keys there if you want. we're not going to do that. We're just going to do the default, which is to store it in the current directory. Oh, jeez. Password. Okay, and so that's created two files, private key, cosigned key, and the public key, cosigned pub. And it kind of looks like that. I think it's ecliptic curved cryptography underneath the hood, but that's beyond my pay grade. So now we have a cosign and we've got a key pair. We want to sign something. So I'm just going to pull an image from the Docker Hub. I've pulled this already, so it should be quick. Yeah. Then we can tag it. There's no way I'm going to spell rejects right every time. Can you see the whole of the screen? Are people struggling to see it? Okay, I'll keep going. So, now this actually won't work, but I'm going to show you anyway. Because it kind of explains what's going on a little bit. So, assuming I spelled everything right, this still won't work. Well, because I'm not doing sign, but apart from that. Because what's happened here is cosign's gone off to the Docker Hub and said, hey, there's no image in the Docker Hub called this. Cosign doesn't care at all about my local like Docker images and so on. In fact, you don't need to have Docker installed at all to use cosign. So what we need to do is push that image. And let's hope this works. And hopefully it won't take too long. And now we should be able to sign it. I'm using that public key to sign this image, and that's being pushed as a blob into the Docker Hub. So to make it a little bit clearer, where was it? Yeah, so the next thing you want to do is verify. So what we can do is -key, cosine. This time use the public part of the key. Did I spell that right? Yeah, and so that has validated, make it a little bit nicer. So this part is literally the payload. And you'll notice, like I was using the tag rejects. Yeah, I was using the tag rejects, but that doesn't actually appear here. All that appears is the reference to the repository and the digest of the image. Because of course, you know, your tags can end up pointing to different things, so what we actually sign is the digest. Cool, and that's verified against the public key I used. And so the next question you might have is, well, hang on, where is this stored? Because you can't store things in the image itself currently. So there's a triangulate command, which is kind of handy because it'll tell me okay, you've got this emote cosine demo rejects. Oh, scrolled off the end. How do I get that? Let me set off the end. Okay, that's better. Right, and so basically, it stored this blob with this .sig extension, and the rest of it is actually the SHA-256 digest of the image, so it should be the same as that. So that's kind of how it stores stuff next to it in the registry. and how it finds the images. Okay, the next interesting thing, actually I can just do this. So we can try adding annotations. Why is that not? Because I pushed up. We can add annotations to an image. So if I do env equals prod, so we could say, okay, I'm saying I'm only interested, I can add, okay. In this case, I'm going to add an annotation that says this image perhaps is marked so it can run in a production environment as opposed to a development environment. It's just an example. So I've added this -a annotation, env equals prod, and I've pushed this. It'll just add another whole payload on top of the other one. It doesn't like merge them. And then what we can do is if we run verify again, we should see our annotation in the payload. Yeah, there you go. And then you can even start saying things like, well, okay, I want you to verify, but I'm only interested if the image has been marked as being able to run in prod. So that should come up with just that one annotation. Yeah. And just to prove that it does work, if I do like dev equals prod, nothing's going to come up. Well, an error will come up. Okay, but now's for the really cool bit, because I don't know about you, but I hate having to deal with like secrets. And you know, the big problem with a whole bunch of this signing stuff is you end up with these like private keys you've got to keep safe. If somebody else gets them, it's a disaster. Trying to like change them and rotate them is a nightmare. And yeah, it's just really not a good time, to be perfectly honest. And frankly, I think it's the main reason that we don't do more signing and checking of stuff. So what I can do is...
So just to cut to the chase, that SigStore then helps get bypass that process where you have to
Well, I'm going to show you right now. Patience. Oh, I meant to pull an image first, sorry. So if I do Docker, pull, so we'll use a new image. We'll have to tag it something. So my mind was kind of blown when I saw this for the first time. I thought it was pretty cool. Basically, if we turn on cosine experimental equals 1, this time I'm going to type sine, but I'm not even going to specify a private key. If I didn't have the experimental 1 at the minute, I would throw an error and say I don't have any key. But we put this on, and we're going to try the keyless signing. What did I do? Sing. So, if we're lucky, then where's the browser going to be open to? It's probably the browser behind this. So, yes, there you go. So, when I typed that in, what it's done is it's opened up the browser and asked me to select an OpenID provider to use. So, I'm going to use GitHub. And that's done that. Why can't I just tab back? That's very annoying. I'm being stupid. Where's my tabs? What? Well, it's because it's full screen. Okay. Anyway. Oh, I didn't push that. That would help. So that didn't actually work. After all that, because I didn't do Docker push. I've not had much sleep. Okay, let's try that again. Oh, that was weird. Oh, that's not what I meant. No, no! Hang on. Let me get this over here. Actually, that's not a bad idea. Well, that is a bad idea. Can I close it? Will I close everything? No, good. Right, so that worked that time. So hopefully, I still don't understand why I can't tab. Right, that has worked this time. And we've now signed it, and there was no keys involved. But it did ask me to validate against an OpenID Connect server. Now, this does get a little bit complicated. Let's see if I can, well, that worked that way. Oh, jeez. Right, so this is kind of what was going on. So the first thing to be aware of, we call it keyless signing. I kind of hate that name in the same way that I hate the name serverless. But it's exactly the same idea, right? You know, in serverless, you have, well, they say you've got no servers, but obviously you do have servers, it's just that you don't have to deal with them. In keyless signing, it's exactly the same. There are keys, you just don't have to deal with them. So what's basically happening is, as a developer, I can request a certificate from the Fulcio Certificate Authority, which is what effectively we're doing there. And to do that, we authenticated with OpenID. Oh, geez. We authenticated with OpenID Connect, which basically meant Fulcio had sort of authority that we, oh, geez, that we had control over whichever email address is associated with an OpenID account thing. So if you go and look at the verification data, I should have done that actually, you'll see that it talks about my email address because that's sort of what's been used to sign it. Yeah, so Fulcio gave us a signed certificate based on that data, which we then used to sign the artifact and send it. Now, both the certificate that Fulcio created was pushed to this record transparency log and the fact that it was signed on a certain date and time. So what that means is end users can now, if they download my artifact or whatever has been signed, the image, they can validate that it is in the record transparency log and that it was signed with a trust root that came from Fulcio. Now, the reason that we're interested in the record transparency log part is because it provides some protection against things going wrong with OpenID Connect, effectively. And also, if, for example, an attacker does get control of somebody's account, because it's in this transparency log, hopefully somebody might notice at some point and there is a record of things. The transparency log is exactly the same idea as a certificate transparency, if you're aware of that from like the previous domain hacks and so on. Okay, what else do I want to show? I'm not sure I'm going to get to the end. I took too long on my demo, I apologize. That was the most interesting bit, though. If you can get it full screen. Jeez. There we go. So what I should have done was verify. Again, you still need to leave that in. And now the Wi-Fi isn't working. Okay, I'm going to show you the last part. I don't think, oh, there we go. Okay. And of course, I didn't run that through JQ, so you can't really see anything. But thankfully, the most interesting bit perhaps is at the bottom, because we do have subject then my email down here. So that's kind of the level of guarantee you're sort of getting, that this artifact was signed by somebody with access to this email, or yeah, kind of with access to this email account at this date. I think there's also a date up here. The other thing I was going to show, but I need to cut things short, I think, is Kyverno as policy management. So I do believe there's a new version of Kyverno coming out that will support keyless sign-in and so on, but I just wanted to show, if you apply this policy, basically what we're saying is all images from Docker.io emote must have a signature, and you can specify a public key. And this, I would copy from the cosign.pub. And that does work. I think we're out of time. I just want to go back to the final slide. So, takeaways, please. Okay. Takeaways, please think about the two questions I posed at the start. Do you know what's running in your cluster, and can you prove it? Sign images is pretty important. I think the keyless sign is pretty cool and solves a lot of problems. Do remember to check your signatures, and yeah, please go away and sign things. Thank you very much. I don't know if we've got time for questions. Okay. Yeah.
For the Kyverno policy verification, if you're using keyless signing, there's no public key. Yeah. What would you do there? Is there like a separate struct?
So I assume, I've not verified this, but I know they've got new support coming out. I assume they use the trust root, which is basically the root keys for the full CO certificate authority. Okay. And then you can, do everything. Okay, in that demo, I was just going to use the public key that I created earlier. Cool. Oh.
They check the record transparency log about because when you push the images, usually the image is there. And then in your policy, you can describe also where you trust, like which subject and the issuer you should trust besides the registry and the image as well.
Okay. Yeah.
Thank you very much.
Okay, thank you.
Up next, we have Andy Randall and Thilo from the Kinfolk team at Microsoft, and they will tell us about how the Flatcar community project is going.
Hey folks, welcome to our talk. I'm Thilo, I'm a manager at Microsoft.
And I'm Andy, I'm Principal Product Manager at Microsoft as well. And for those of you who have followed me on Twitter, you may see I got here to Valencia from Berlin by train. And if you take a train and you look out of the window at any of the goods yards or places you might see shipping containers, you will see pictures like this, a container, and how do they get it on the rails? Well, that thing that it's sitting on is called a flat car. So that's where the name Flatcar comes from. For the Flatcar Container Linux, it's a minimal, lightweight foundation for running containers on. Pretty simple. Makes sense when you know that. So what do we mean by a container Linux? Really, there's kind of 4 key attributes. The first is it's a minimal distro. So if you're running containers, most of the dependencies that you need are contained within the container. The distro itself doesn't need a whole lot of baggage along with it, so it can be really small, if really pretty minimal. The second aspect is that we want to design this for security. We make the actual file system that the OS is running in immutable, and there's a whole category of exploits which exploit the fact that you can change the running OS, and those just don't work on an immutable file system, so it's a secure environment. Another aspect of security and manageability is the fact that it's a built-in update system, so it takes automated update, applies updates as they're available on an automated way, policy-based way, and you can update them according to schedule or whatever policy you apply. And then the last piece is declarative provisioning, and really in the same way that we think about workloads and nodes as as kind of disposable infrastructure as code, we should be thinking about provisioning our operating system in the same way. So you have effectively very simple bits of code which define how the node is provisioned. And what this all adds up to is operational simplicity for security and manageability when you're deploying at scale. So deploying 1 or 2 nodes in your home lab, running Kubernetes on it, probably not a problem. When you're deploying hundreds or thousands, these kind of issues really come to bite you, and it's where you really start to see a difference. In fact, there's a great quote. We did a case study. Equinix Metal actually migrated their bare metal cloud control plane into Kubernetes and used Flatcar as the underlying layer for that. And it's almost like night and day in terms of how it was to manage the traditional full Linux distribution that they were using before to how they would manage on Flatcar. So they just don't think about the OS anymore, and they can focus on the workloads that they're deploying on top. So this is just like the what Flatcar is in a nutshell, and where it comes from actually is it derived from an operating system called CoreOS Container Linux, which goes back to 2013, and it itself was inspired by Chrome OS, which came out of Google, and had applied a lot of these same concepts to desktop operating system for Chromebooks. That's how they make Chromebooks simple, secure, automatic updating, and we basically translated a lot of those concepts into servers. So we actually decided to launch the Flatcar project as effectively a fork of CoreOS back in 2018, when the company behind CoreOS was acquired by Red Hat. And shortly after that, in 2019, I spoke at the last big in-person Rejekts event in San Diego and talked about Flatcar and really kind of introduced it to the Cloud Native Rejekts community. And that was one reason why we thought today would be a good day to come back and just kind of give you some updates on where the project's been and where it's going. Because that's, believe it or not, 2.5 years ago. And there have been some pretty significant developments in terms of the project in that time. So the first, and probably from many users' perspectives, the most important one was the original CoreOS Container Linux reached end of life. And this was something that we've been seeing was probably on the cards, and the reason why we introduced Flatcar was we wanted to enable a seamless migration path for users going forward who had deployed CoreOS. And so that took place. And then more recently, the team behind Flatcar was based in Kinfolk, and we were acquired by Microsoft, in fact, pretty much exactly a year ago. And we had a lot of questions around that time about, well, what does this mean for Flatcar? We've got a lot of users on it. What's Microsoft's commitment to this? So we headed off some of that at the time. At the time the acquisition was announced, there was a blog post by Brendan Burns. And he was very explicit in this. And in fact, through the acquisition talks, we had the question put to us: how do we make sure we don't do a red hat on Flatcar? Because we don't want to, we don't want this project to end. We want to basically reassure the community that we're going to continue to work with them and to transition this to be a much more community-driven operating system, much more community-driven project. And that was the commitment at the time, was that we as a team will continue to work with the community and, in fact, even kind of double down on that. And I'm going to hand over to Thilo at this point to talk about how we've actually made that transition from vendor-led to community-driven. So Thilo, take it away.
Thanks, Andy. Yeah, that's an exciting experience and phase for me, both as a nerd and as an engineering manager. So the new position enabled us to fully open up to the community because the requirement of having like a vendor drive in the project was gone. So we opened up the build system. We made it technologically a lot easier to onboard with Flatcar. We containerized the SDK. So onboarding and development is a lot easier. We simplified and are still in the process of simplifying the build system so that it's easier to set up your own Flatcar build if you so desire. We introduced community calls, like we have monthly, call it office hours, where we show like the latest stuff that happens in Flatcar. We have a room for our users to speak up. We have folks visiting us, presenting to us. And we also made the security process a lot more public. That was something that was a subscription thing before. So we're involving the community. We're having early notice out, and we're making sure that this part is not premium. It's also covered in the community sector. Yeah, what else? The release planning was public, and that was an interesting experience as the manager of the Flatcar team. So that was basically an internal meeting that we just put on Zoom and made it public, and had other people joining us and looking at how we conducted release planning. So that was very exciting to see. And so some of the things that we achieved after disconnecting ourselves from CoreOS, because CoreOS went in maintenance mode, and we just felt that we need to push innovation a little more than CoreOS did back at the day. We modernized almost all of the packages, huge kernel updates, kernel version jumps. We had several major systemd updates, Docker updates, like the very core. As mentioned, we modernized the way the SDK works as well. To just make it easier for people to contribute to Flatcar. There were a number of retirements that we did. So there was an Edge channel, which we took as experimental, and we didn't need that anymore at some point, because changes just went into alpha and then got mainlined. We discontinued shipping the Rocket container runtime, so everything's Docker-based now, and we're looking into new options in the future. SDK was really an important step for us, and there's still some work to do. But the way CoreOS was built was pretty arcane, and it was hard to onboard. It was a pretty tight learning curve. And right now, it's as simple as cloning a repo and running a script, and you're basically in the SDK and can start developing. We introduced an LTS channel. So our stable releases major stable releases usually go out every 2 to 3 months, and for some people that is a bit too rapid a update cycle. So we have a long-term support channel that holds over a year and only receives bug fixes and patch updates. We added GPU support right after deployment. Right now, this is only for Azure, but work is on the way to generalize that and make it basically work on any platform with GPUs. We introduced FIPS. And that is important if you need certification and if you need your clusters to check certain boxes. So Flatcar supports full FIPS mode. We worked a lot with upstream. So we have several upstreams, of course. We did work with Gentoo, where all of our packages are derived from. We do stabilization work for them. We fix bugs. We are working on with Fedora Chorus folks on several key components, some of which we are currently using, which is Ignition, which we updated as well. Some of which we are planning to use, which is Butane. Butane is a config transpiler that transpiles human-readable YAML in less human-readable JSON, which is fed to the provisioning process and configures Flatcar instances. We've been working a lot with the Cluster API and other Kubernetes projects. We have a lot of patches in Image Builder, and we've upgraded Ignition version 3, and we have backwards compatibility. That is something that Fedora Chorus choose not to do. It's important for us that our users just continue, are able to continue using our operating system without major changes. We understand the pain of operational work, and we basically want to keep that from users. So our Ignition ships with version 3, but also supports version 2. We've made a big jump into cgroups v2, and since there still is a lot of friction and unreadiness for cgroups v2, particularly in the container world and the Kubernetes world, we still fully support version 1, and it can be configured so at provisioning time or at runtime. We've added full support for ARM64, and we test regularly all of our releases on Ampere, on Graviton, and on the new Azure ARM64 offering. And we have support for EKS worker nodes on Amazon. So, some raw numbers. Since we detached from Chorus and basically learned to walk by ourselves, we have more than 300 bugs reported and fixed from users. We have more than 250 packages upgraded, and all of Flatcar is basically 320 packages. So we went through a lot there. We had 35 major alpha releases since we detached in late 2019. And only in the last quarter, we had 550 contributors interacting with Flatcar, with the GitHub project in some way, be it bugs being filed or even PRs being filed. And
Great.
Back to Andy.
Thanks, Thilo. Yeah. So as you can see, we've been doing a lot on the engineering side. The project team is really, not slowed down at all. If anything, has really accelerated, including over the last year. And this has translated. We've seen, CoreOS supported already a lot of platforms. We've seen a lot more, ecosystem partners coming in and integrating and enabling Flatcar as an OS. From obviously all of the major clouds through to the cluster API integration work that Thilo, he kind of glossed over that. That's been a huge investment, actually, working with the cluster API upstream groups in VMware and in Microsoft and across other companies as well. A lot of folks putting a lot of time and effort into cluster API as the new standard way of provisioning Kubernetes clusters, and Flatcar is being supported out of the box now in cluster API, and really kind of across a wide number of distributions. And we do see, and I mentioned Kubernetes there. We did a survey recently, and we found about 80% of our users were actually deploying Kubernetes, but that also means that there's a good number that are not deploying Kubernetes, right? They take Flatcar for deploying containers in, maybe they're just manually deploying Docker onto nodes and deploying containers in that way. And so there's some of that too. We're not Kubernetes exclusive, but it is the most important of the environments. Now, this is quite an interesting chart because I showed you that picture of me standing in front of the Cloud Native Rejekts. And if you look at where we were on the adoption scale, it felt like we had quite a few users back then. But now you can't barely distinguish that from zero, you know. Clearly through 2020, you know, the big driver was the folks who had CoreOS deployed, who needed a solution to migrate onto to continue getting security updates. But you know, even since then, you know, over the last 12 months, we've seen nearly 50% year-on-year growth, and that's coming from people that are choosing Flatcar not because they had CoreOS and need something compatible, but because they want a great foundation for deploying containers, and also increasingly people like the fact that this is, you know, really community-oriented in the direction we're going with the project in really opening up to the community. So you can see some logos of a lot of folks who've, who have deployed and adopted and integrated Flatcar, but it's with the kind of numbers here. I mean, I don't think we've shared these specific numbers before, but you know, you can see we're up to like 50,000 that are pinging our update server, and you have to bear in mind that that is a small subset of the total deployed number, because a lot of people will not want to go to the public update server to pick up new updates for a whole lot of reasons, including a lot of people are not necessarily applying updates, they're just redeploying, re-imaging nodes with a new version as it's available rather than doing in-place updates. So we see pretty good adoption there.
So what do you attribute that growth to over the past year?
We're riding the fact that Kubernetes is taking off, containers is taking off, the world is moving to containers, and the fact that, you know, a lot of people within that, within that community are adopting Flatcar as a great basis for those deployments. You're a great straight man. So we asked people, why are you adopting Flatcar? What do you like about it? And security and manageability are the two big things. So really, kind of the decision comes down to typically, you know, a full Linux distribution, an Ubuntu or RHEL or something like that, right? Which has the advantage that it's well known, the folks know how to manage those nodes, but you know, it doesn't have the same kind of characteristics I talked about early on with the immutability, automated updates, and these kind of things, and the manageability that comes from the way that we deploy nodes. The fact it's small and lightweight, you know, integrates with the integrations that are there. There are other OSs that are around with, which support Kubernetes well, but maybe are not supported across the breadth of the breadth of platforms. And you know, I think, you know, anyone who's worked in product knows, you know, the Net Promoter Score, particularly early on, like if you have users that love and have a great experience with your product and go around recommending it to people, then word spreads, and that's how a lot of this has happened. Looking ahead, there's a lot of things that we can still do. We think, you know, it's important to be clear that, you know, we're not in the job of just like keeping CoreOS in maintenance mode and just kind of continuing exactly as it is and just applying some security fixes as they come out. You know, this is an active development project. Of course, the most fundamental thing we do is to do all of that basic maintenance and to ensure that we are keeping up to date with the latest releases and packages and everything. But there's a lot of work that's happening in the community beyond that, the cluster API work that I mentioned, but also, you know, we just heard about supply chain security. We need to think about, well, what does that mean for an operating system? How can we make our releases, attestable and verifiable? How can we integrate with the TPM hardware that's out there? All of those kind of things topics we're working on. Slack channel may seem like a small thing, but a lot of people are saying to us, we want a Slack channel to be able to talk to you. So, you know, we chose to use the Matrix open source chat tool for our team chat and opening that up to the community because it seemed like an open thing. But, you know, there's a lot of folks, particularly in the Kubernetes world, that have the Slack open. We've actually submitted to add a Slack channel into the Kubernetes Slack. So hopefully that'll be created, unless it is already. Do you know?
We miss one sign-off of an admin.
Okay, so we're nearly there. And the other thing is just like growing the ecosystem. I've had a lot of conversations with folks in the community, from larger companies to smaller companies, that want to get involved, put contributors into the project and really kind of integrate Flatcar into their products. And so you're going to see more of that happening. And the other thing that comes up, just because we are now part of Microsoft, and Microsoft is open source friendly, but is also a large company, and there are a number of people that say to us, we would really like to see this having more neutral governance and kind of guaranteed neutral governance. So we are looking at options for how might this go into a foundation. So nothing to announce there, but it's it's certainly a direction that we we see makes sense for this project. Given our strategy and what we're trying to do. And beyond this, I mean, everyone in this room, everyone listening on the live stream, you're welcome to participate. We've, literally every aspect of the project is opened up now. This, I'm talking about futures here in a summary form, but you can go click on that GitHub link and interact with all of the issues that are there, and add your own request, add ideas for things you want to do, how you want to participate. You can join the monthly calls, you can join release planning, you can join the team Slack and interact directly with the engineering team. This is really, we don't want to see this as something we control. We want to see this as, really the community's container Linux, right? This is something that we want to be as a foundational element of the entire cloud native stack that the community can build on. So I wanted to wrap up there, and hopefully a couple of minutes early, and really just see if there's any questions that we can see it through to the next slot. Yeah.
Hi. Thank you. It was a very interesting presentation, and it's a very important topic. So now there is no overlap with what Core OS, because you're working with also Fedora Core OS you mentioned. But how about Talos and any other container operating system? And you mentioned also that there are workloads that are not Kubernetes related. What are they?
Yeah. So there's two questions there. I'll take the second one first because it's simpler. I mean, the fact is, basically, there are people that are deploying containers. I mean, believe it or not, I know we're at KubeCon, and some of you may not believe this, but there are people deploying containers that are not using Kubernetes. And literally, they'll create an ignition config which just installs maybe a systemd unit that starts a container or two or 100, and that's it, right? And that's all of the configuration that they need. So for people who don't need that dynamic environment, that maybe that. Also, I spoke with a customer using Docker Swarm as well. So there are other use cases. It is mostly Kubernetes. In terms of working with other distributions and communities, with Fedora Core OS, it's more there are ancillary projects. So things like Ignition, right, which is it's the way we take the configuration for the node for the first time. The first time it's actually run after it's been deployed, and there's no reason for us not to collaborate where that makes sense and to leverage that upstream project. I mean, Talos takes quite a different kind of approach. I mean, I know the guys, we support them. I wish them well with what they're doing. It's just a different kind, maybe slightly more radical kind of view of what a Linux container or what a Kubernetes Linux OS should be, and that is specifically targeted just at Kubernetes, is my understanding.
So Talos and BottleRocket, I believe they are API driven. So basically, you manage them using an API, but in your case, you are still using the SSH.
It's different. The philosophy of configuring and deploying is slightly different. So for Core OS Container Linux and for Flatcar, the idea is to make a configuration exactly once at provisioning time. And you just basically write YAML. It's being translated and then interpreted by the node when the node comes up. Everything dynamic should be in a systemd unit file, so when it reboots, then it basically comes up in the state you want it to come up. I think the balance that you need to strike when you offer an API to interact with nodes is to actually keep it as easy as it currently is. So you would invest into a new technology and then at the same time make sure that the user isn't forced to use it but can use it, right? And to strike that balance is an interesting challenge. And I believe BottleRocket and Talos do implement some fundamentally different philosophy there. So you have to have the management somewhere, right? In our case, it is something that the node should do. It should be halfway intelligent and make the right decisions for you. So you can basically focus on describing the business logic. And for other philosophies, for other configuration philosophies, that's different.
Yeah, thank you for your presentation. I wonder why you decided to retire Rocket and introduce Docker. As I'm seeing, like in my perception, a huge part of the industry is moving past Docker.
That's an easy one. The project was deprecated.
Yeah.
Right. So the Rocket project itself was end of life.
And we didn't introduce Docker. We always shipped Docker.
Yeah.
So we had Docker and Rocket in parallel on the system. We just basically decided for the slightly more lively one. Containerd is there, and you can actually, obviously, use it with a few modifications. Docker will be around. We are working on more composable images, which is a challenge if you're a immutable distribution that doesn't use any packages. But there's some technology, systemd sysx, that we're looking into to achieve exactly that. Also, pick a different container runtime in the future, something like that. While we don't have anything to announce yet, that is definitely on the roadmap that Andy showed.
Thank you very much.
Thank you, Margot. Thank you, everyone.
We have a short break now, and then we will be back with 2 more talks.
estrella le guiaba para seguir su camino.
All right, we are back. And it's time for our talk from Ankita and Ashutosh from VMware. And they're going to talk about declarative lifecycle in Kubernetes clusters.
Thank you. So good afternoon, all. So today we are going to talk about declarative lifecycle management of Kubernetes clusters on various clouds. But before that, I would like to introduce ourselves first. So hi, I'm Ankita Swami. I work as a member of technical staff at VMware, and I have been actively contributing in Cluster API and its provider for AWS, and I'm actually a reviewer for the Cluster API provider AWS as well. And I would like Ashutosh to introduce himself.
Yeah. Hello, everyone. I'm Ashutosh, and I work at VMware, and I'm also an active contributor to Cluster API provider Azure. Prior to this, I was working with OpenEVS project, and this is a new project that I've been kind of exploring in the last couple of months. So hopefully we'll have fun here. This is the agenda that you can see on the screen. So we are going to cover around Cluster API, its ecosystem, and how the lifecycle management of Kubernetes clusters are made easy, that too in a declarative pattern. And we'll share what we have learned while we try to contribute, and then we'll have a demo at the end where we'll try to create a Kubernetes cluster on Azure and upgrade it or scale the worker nodes. Yeah, Ankita, you can start.
Okay. So as we know that Kubernetes is a complex piece of software, provisioning and managing the life cycle of the Kubernetes cluster is quite tedious in our day-to-day operations. So imagine if we have a situation where we have to manage hundreds of clusters and we actually have to provision the production-grade cluster. We have to manage the life cycle of each of those production-grade clusters, and it can get a bit tedious if we are talking in that scale. So the situation can get even more worse when we are actually operating these Kubernetes clusters on different infrastructures like AWS, Azure, GCP. So though KubeADM is a tool that actually solves the problem of installation of Kubernetes, but it does not help with the lifecycle management of the Kubernetes cluster. So here comes the Cluster API as a rescuer. Cluster API is actually a Kubernetes 6 sub-project which can be used to manage the lifecycle of one or more Kubernetes cluster. But before we get deeper into what this Cluster API is, we would go through a recap of Kubernetes controllers and how it works.
Cool, thanks. Okay, so how many of you have written a Kubernetes controller or you're aware of? You can raise hands. Okay, cool. So there was a wonderful talk that my colleagues Sivani and Madhur gave around CRDs and conversion. So I just want to give a little recap of how controllers work. So this is a little picture that I made. I'll try to explain this, what I mean here. But Kubernetes, when we say declarative APIs and reconcilers, what we mean is, we define how we want our system to be in a YAML, and there is some process or reconciler or controller, whatever we can call, it actually keeps reading that state, and it tries to take some actions, to actually convert your system onto what you have specified in YAML. For Kubernetes, typically it is a YAML file, and if you can see, it's a dummy code that I've written, until and unless the current state that is captured in a YAML file does not match to your desired state, the controller is going to take actions to do so, right? And a couple of points that you can see. So the benefit of this reconcile pattern is that you usually do not instruct what to do. You specify how you want your system to look like. For example, somebody gave an instruction that, can you please add one replica because I want, to have 2 replicas, and there can be high chances that that instruction got missed, maybe due to some networking thing, and you may never end up into having 2 replicas, and that is what you wanted. But at the end, the second kid, he said, I just said that I want 2 replicas, and the controllers on the background is going to check, okay, what the system is right now in. The current state is 1 replica, but the intent says that I want to have 2 replicas, so the controller is going to take actions to do so. These replicas, you can think of like pods, right? When we have a deployment and we say this many pods we want. So this is typically the controller's recap that I wanted to go through, and this CAPI ecosystem is nothing but a controller that is based out of KubeBuilder. You could define your Kubernetes infrastructure on YAML. You can just do a kubectl apply of that YAML, and it is going to provision your Kubernetes cluster on the desired infrastructure. We'll come more on how this different infrastructure hooks in with this CAPI. Okay, this is the CAPI ecosystem that you can see on the screen. So essentially, you have a declarative config. This declarative config is nothing but a YAML file where you specify, I want Kubernetes version x.yy, and you just do a kubectl apply, and this CAPI components, you can install that on a Kubernetes cluster itself, and when it is done, when you do apply this declarative config, it can potentially provision your Kubernetes cluster, depending on the cloud that you have asked for. So if you can see, second and third point, how this CAPI work is, you do have a core controller that we call as CAPI, Cluster API, and then you can choose to initialize with AWS or Azure or GCP. That will install the provider controllers. So essentially, on a high level, there are two controllers. One is the core CAPI controller, and then the provider controller. The responsibility of the provider controller will be to, kind of issue instructions to the respective provider. If you have, let us say, Azure provider, it is going to issue instructions to the Azure APIs to create VMs, networking, and stuff like that. And we have a couple of keywords like, bootstrap cluster, management cluster, and workload cluster. So let me give a walkthrough of this, and in the next slide, we'll understand it in more detail. So, a bootstrap cluster is a simple client cluster that you can, so you first create a client cluster, and then you install CAPI and other providers. You have option, you can choose to install provider for Azure or AWS or all of them. And, once you're done installing that, you could actually migrate this bootstrap cluster into a more production grade, for example, on Azure or AWS. So the difference between bootstrap and management cluster is essentially that, management cluster becomes a little more production grade. Now on that management cluster, you could typically do kubectl apply of that declarative config. We'll again see this, we'll expand this declarative config and we'll see what is in there. And once you do that, from that management cluster, you could potentially create different workload clusters where you could deploy your applications. And this could be on Azure or AWS or GCP. This is a little diagram that I made. So this is a bootstrap cluster. And then we migrated everything what was into this bootstrap cluster to a 3 control plane node and 3 worker node Kubernetes cluster, let's say on Azure or AWS. So what essentially this management cluster has are those CAPI and provider pieces that you can see CAPI pods and cap star pods. Star means you could have for Azure or AWS or GCP. And bootstrap cluster is similar in that sense. It's just that we may not be able to maintain this bootstrap cluster because it is a kind cluster. And once you are done with your management cluster, you can do kubectl apply cluster, and you can create a cluster on Azure or maybe on AWS, or you can see kubectl get cluster. You can get a list of clusters, that are created on different infrastructure. To go like a little more into providers, I'll invite Ankita.
So if we talk about the core cluster APIs, we have some CRs in place, the custom resources, like cluster, machine sets, that are actually reconciled by their own respective controllers. Similarly, even the cluster API providers also have similar kind of APIs or CRs. Like suppose if I take an example of cluster API provider for Azure, so it has Azure cluster and Azure machine, which again have their respective controllers, which takes care of creating the actual infrastructure, like doing the network setup, creating the virtual machines, creating load balancers, etc. So there are many other APIs that are actually offered by Cluster API, but we have ignored them as of now for simplicity. So there is a correlation between the core Cluster APIs and the provider APIs. So these cross-references are actually, the Cluster APIs are actually providing the blueprint to the provider APIs. So when we actually set the statuses and conditions on each of the CR objects, this actually enables us to providing the wiring between the core cluster APIs and the provider APIs. So the status and conditions actually plays an important role here to make this coordination happen. And also, this cross-referencing actually helps Cluster API to provide a plugin capability such that any of the providers can actually work with the Cluster API in conjunction. So there are other providers as well which are actually provided by the Cluster API, core Cluster API. One of them is KubeADM control plane provider. So there comes the KubeADM control plane provider, which actually takes care of managing the lifecycle of the control plane nodes. The KubeADM control plane provider is a default one that is provided by Cluster API, but you can feel free to bring your own provider as well for managing the control plane lifecycle. Also, similarly, we have Bootstrap KubeADM controller provider, which actually takes care of bootstrapping the Kubernetes nodes, and it helps in joining the nodes to the Kubernetes cluster. Again, this CAPI provider is actually a default one, which is provided by the Cluster API. So here is an example to actually explain all those terms which I have used as of now. So let's say that we actually want to create a simple Kubernetes cluster on Azure. What do we want to do for that? We actually want to apply a YAML onto the Kubernetes cluster, which will have the Cluster API and the Cluster API provider for Azure, which we call it as CAPI provider, installed on those. And once those gets installed, these are the list of the CRs or the APIs that comes with it, and it gets created on the cluster. So first one is the cluster, which comes from the core Cluster API. Then Azure cluster, as name suggests, it comes from the Cluster API provider for Azure. Then we have KubeADM control plane, Azure machine template, machine deployment, KubeADM config template, and again, the Azure cluster identity, which is used for the authentication purpose. So we will go in detail regarding all these CR objects one by one. So first comes the cluster CRD. So actually, a cluster is defined using the cluster CRD. So what this means, it actually defines the cluster resource spec, which can actually help us know how the networking is set up, what CIDR blocks we are going to use, and actually what we are using as the domain names for each of the services. And with respect to that, we also have the status set on these objects, which will tell us the informations like the endpoint, IP address, or the port. So the cluster controller is actually responsible for reconciling the cluster CRD config. And we can notice that here we have reference to KubeADM control plane and Azure cluster. As I mentioned, KubeADM control plane is a control plane provider, and the Azure cluster is the infrastructure provider. So this cluster controller actually waits for the infrastructure creation to complete, and then it will sync its status accordingly. Now, the Azure cluster is also created by the cluster controller, which actually deals with creating the actual cluster on the Azure infrastructure. And it also makes the control plane nodes and machines ready to use, such that the overall cluster status is healthy. There is one more usage of the cluster CRD is that it actually creates the kubeconfig secret for the workload cluster so that we can have access to the workload cluster. The next comes machine deployment. Again, the machine deployment can actually provide the declarative updates to the machine sets, which in turn creates or deletes the actual machines. So if we see the correlation, machine deployments is actually analogous to the Kubernetes deployment. The machine sets is analogous to the replica sets, and machines are analogous to the pods. So here, actually, the machine deployment takes care of unowned and unmanaged machine sets inside the cluster. It actually also takes care of reconciling the changes to a machine spec by rolling out two changes. One is the old, and other was the newly changed spec. And finally, the machine controller actually takes care of creating the provider-specific machine using a template. That is Azure machine template that you can see inside the infrastructure ref mentioned in the YAML. KubeADM control plane. So it is responsible for managing a set of control plane nodes inside the cluster. KubeADM control plane provider is actually, again, a default provider, as I have mentioned in the previous slide, which actually takes care of bootstrapping and also takes care of scaling and deletion of the control plane nodes. Again, unlike the worker nodes, these control plane machines do not have any machine deployments. So that's why we need a provider to take care of all this. So as you can see on the screen, this API has actually the capability of ingesting some of the control plane configuration flags, which can be used to install the Kubernetes components like API server and controller manager, etc. It is also responsible for initializing the Kubernetes control plane with services like etcd, API server, kubeproxy, CoreDNS, etc. The next one is KubeADM config template. It actually defines how the machines should be bootstrapped and joined to the cluster using KubeADM, that is the provider I was talking about. You can also notice that this configuration was actually referred back in the machine deployment, and where actually each of the machines follow these bootstrap template to join to the cluster. Ashutosh, you can just go ahead with the other slides.
Yeah. We just, took a look around the APIs that are there, to kind of give a sense of how we can provision a Kubernetes cluster. This is the resource hierarchy. You have a cluster, that kind of maps to a workload cluster. It could be on any of the infrastructure. And then you have machine deployment. So the role of machine deployment is similar to the role of deployment. It just makes sure that you roll out your machine worker nodes. So you can understand, like, if you have 3 worker nodes, right, you can have a machine deployment that specifies that I want to have 3 worker nodes. And machine set is the one who is responsible to, keep the desired state to what you have stated. And this machine CR is the actual machine CR, which is kind of consumed by the provider controller. And that provider controller is going to actually create machines on the infrastructure. Because we are taking the example of Azure, we can say that this is the machine CR, and this machine CR will have all the information captured in there, and the controller would actually act upon that by doing the Azure APIs call to finally stand a real machine. And then we have KubeADM config and Azure machine. So what happens is, like, machine CR is actual and general representation of your machine. But for Azure, it becomes an Azure machine. Similarly, for AWS, it will be an AWS machine. For example, if it is an AWS specific things will go onto this AWS machine. And how it happens is via templates. Maybe we'll see a demo, and then we'll understand how this information flows through it. You can see this is the Azure cluster CR, and it has like more specific details on what should happen on the Azure infrastructure, like the subnets, what are the subnets that we want to create, and you specify the subscription ID. This is the Azure machine template that I was talking about. So when you create a machine, by using this Azure machine template, an actual Azure machine is created. Now that actual Azure machine will have all the required information for the controller to, bring up an actual virtual machine. Let's see a demo. I'll just play the demo. I've just pre-recorded it for the sake of time, so let's watch this demo.
To authenticate to Azure Cloud. This is very straightforward and can be found on the cluster API doc link. I'll share the relevant links in the next slide. But let me just pull out the pods here. So these are the pods in the kind cluster. You can see this is the CAPI controller manager and this is the CAPI controller manager. So this is actually cloud provider Azure. Control plane provider that we were talking about in previous slide, and this is the QADM bootstrap provider. Let me show you the secret that is created. So this is the secret that I created. This is used for authentication purpose to Azure Cloud. And now let me just show you the YAML that I generated using cluster CTL. This is the cluster YAML, and then we have Azure cluster. And you can see the QADM control plane where we have arguments for API server, controller manager, and we can see the machine template reference for control plane machines, and we want one replica, and the version should be 1.22.0. This is the Azure machine template for control plane machine. And this is the machine deployment where we have replica count as well, and the version is 1.22.0. I'll just apply this one. Got applied kubectl get clusters. And we can see that the phase is provisioning. We can also use cluster CTL to describe this one. Cluster CTL, describe cluster, KCD demo cluster, and we can see what phase the target cluster is in. So, right now we have like cluster infrastructure which does not have any state to true, so it's still in the provisioning state. So let us pull kubectl get Azure machines, and it is waiting for cluster infrastructure. So it will take some while to get these VMs created on the Azure cloud. Well, it takes a little while to get this created. So we have again fast forwarded the video for the sake of time, and now kubectl get Azure machines. We can see that the machines are succeeded. Let's also run cluster CTL describe command, and we can see that the status true for cluster infrastructure, control plane, and worker. We can see a warning here, and this is because we don't have a CNI provider installed yet. So before we do that, let us pull the kube config for this target cluster. So cluster CTL get kube config, and the name of the cluster is KCD cluster, and we'll do demo.kube config. And let us use this kube config to see the nodes, kubectl get nodes, and then kube config, demo.config, kube config. Yes, we can see two nodes. One is control plane node and one is worker node, and the version is 1.22.0. Let us install a CNI provider here. So I've already ran this command some time back, so I'm going to search for it. kubectl apply hyphen kube config demo.kube config, and this should apply the Calibre CNI YAML on the target cluster. Cool. Let us say if the nodes are ready yet. It can again take some while to get the status updated to ready, but this should be quick. Yes, the nodes are in ready state now, and now I'll just quickly try to scale up the worker machine. I'll add one more worker machine. To do that, kubectl get machine deployment, and I'll edit this machine deployment. Let me just copy this one, and kubectl edit md, and I'll search for replicas. I make it 2. It is getting edited. I'll again run cluster ctl describe command. And as you can see, it is waiting for other scenes because now we want 2 replicas. So let's see if that got created. kubectl get machines. We can see there is one machine that is in provisioning state from last 21 seconds. kubectl get Azure machines. And this is the new machine that is being created. kubectl get Azure machines. So we can see that the bootstrap is in progress. So is it? Let us see. Yes, so the Azure machines have succeeded now, and we'll do once more cluster ctl describe. And yes, everyone is true. Now let us see that we can actually see the nodes. We can see this new node that got added 93 seconds back. And now we will try to update this Kubernetes cluster to 1.23.
Yeah, so is it audible? For the interest of time, I'm skipping the upgrade part, but this is how you can do via the kubectl edit and just propagating the information on the YAML. This is very useful. I found it very interesting when I started to contribute on the project. You can do kubectl and put everything on the YAML, and you can create a Kubernetes cluster and do the lifecycle management, upgrade it, and stuff like that. Obviously, there are complex use cases, and feel free to reach out to us. And let me move to the slide. So this is what I wanted to show in the demo, and I have added some links how you can get involved, on the Cluster API channel, or you can suggest your use cases. Do you have any question? This is it for the talk, and this is what we wanted to show. Thanks.
Thank you. Thank you very much. It was a very interesting demo. Unfortunately, we don't have time for questions.
Yeah, we can talk. Yeah.
But yeah, maybe if you have questions, you can ask them while we give time for the next speaker to set up.
That's good.
sexy. Dance with me. Dance with me.
I need you.
Dance with me.
I need you.
Dance with me. Dance with me. Dance with me.
I need you.
Dance with me.
I need you.
Dance with me. Get sexy.
I need you.
Dance with me.
I need you.
Dance with me.
I need you.
Dance with me.
I need you.
Dance with me. Get sexy.
2 and 2. Hear me? Okay, so we had the last talk today for the people watching live, and she won't be there today, so that's the end of this first day, so we'll see you tomorrow.